Okay, first of all, thank you and good morning to everyone. Welcome to this event to Plastics in Action, Overcoming Recycling Barriers and Enabling Circular Solutions. This is a very warm welcome to all colleagues joining us here at Textile, one of our Volume Consortium members, and also to everyone joining us online, partners working across the textiles and plastics value chain. Your presence reflects the collaborative spirit essential to accelerating circularity. Today's workshop aims to create a shared space where we can openly discuss key technological, economic, and regulatory challenges affecting textile and plastic recycling and explore practical solutions that can strengthen circularity at scale. Throughout the day, we will hear from demosite, industrial actors, civil society, multilateral institutions, and research organizations. Together, we aim to identify actionable pathways to accelerate a sustainable transition. Importantly, this afternoon enabling session will feed directly into the preparation of a memorandum of understanding, a document summarizing the shared barriers and opportunities identified today and taking the perspective and the work of everyone, alongside a preliminary set of joint actions that our organizations can and may undertake together. This memorandum will be read and formally signed after this event, and it was for that during the registration we ask you about the willingness to be part of not of this memorandum. Of course, the content will be read at the end of the workshop, and then we can arrange the delivery of the document. For starting this workshop, we have remarkable representatives across multilateral institutions, European programs, industries, civil society, and research. It is my pleasure then to introduce our first speaker, Mr. Humberto Lopez from the World Bank Group, country director from Turkey, with more than 30 years of experience in economic development and international finance. He has held senior leadership roles across Latin America, Sub-Saharan Africa, and Washington, D.C. His work has shaped global policy dialogue on fiscal sustainability, competitiveness, poverty reduction, and public investment. He holds a PhD in economics from the European University Institute and has authored influential studies on growth, inequality, and macroeconomic stability. So, without any other prelude, please, Mr. Lopez.
I don't need to be here, no?
Oh, it's okay.
Thank you. Thank you very much. Thank you for having me here. Really pleasure to be here with you. Let me tell you, first of all, that for me here, this is an opportunity to learn and to listen to you, perhaps more than to contribute the recyclable industry. But before I start dealing with that, I want to share with all of you a couple of personal experiences. My wife and I had 4 kids, boys to girls. The boys are the older, the two girls are the younger. And a year back, the younger girl, my turn, she came saying, Papa, I'm not buying clothes anymore. I'm going to start buying only second-hand clothes. So, fine, 24 at the time. I was saying, listen, if you have a problem with your finances, can help you. I will buy you some clothes. And no, you don't get it. I don't know. You are quite young, but I see somebody here that probably have some kids that are in the late teens or early 20s, and we get that a lot, that you don't get it. You understand? Say, what is that you don't get it? Say that sustainability is important. If you knew the amount of clothes that are not being recycled, you would be really astonished. So for her, buying second-hand clothes and for her clothes is part of the sustainability story. She had continued like that for 4 years. It's a big fight with her sometimes, say, listen, let me buy some new clothes to go here, to go to see your grandma or whatever. It's a big one. Then we have one of the boys, the second boy. He lives in Australia, and after studying public policy, started working in a think tank on sustainability. And that is a good opportunity also for me to listen what are the concerns of the private sector, what are the concerns of companies that are into society. Companies that you rely to basically convert what it should be waste into what it would be. And in many, many cases, it's not so much the spirit, it's the regulation. You want to have a firm that is sustainable, and sustainable here is financially sustainable. You need to have regulation that is going to ensure that you are going to have volume. Because if you don't have volume, you are not going to. This is a question mark for them. Now, pivoting towards Turkey, which is where we are. Turkey had a good track record. You go to 2017, the country started with a zero waste action plan. This is an initiative that was supported by the First Lady, the country, and clearly that gives an idea of the buy-in from a political point of view. But even after that, you have the Green Deal Action Plan 2023, and 2025 you have the 12 National Development Plan. And in all these plans, you have circular economy at the center, the recycling. Why? I think that there are a couple of good reasons for that. One is that this is a country that, to a large extent, is exploring the beauties of the country. It's being both removed this part, and we are having a clean country in all the senses. It's extremely important. So, ensuring that you're not going to have waste in the wrong place, this is going to be quite there is an economic incentive. On top of that is that Turkey needs to adjust to the EU regulations. Turkey, the EU is the main trading partner of Turkey. There's not just a question I want to do here because it's important for me, because if I want to continue trading with the EU, I need to adjust. And this is where the country moved. Early this year, in 2025, the World Bank published a study, Circular Economy Transition in the EU, the EU ecosystem or something. You see, if you Google circular economy Turkey, World Bank, you're going to find that report. Basically, what we were reflecting there is what needs to be done for Turkey to move ahead. What we are seeing is, listen, there are opportunities and there are challenges. One of the challenges is the need to adjust regulation. We have to face that there are costs to some of these adjustments, but at the same time, we need to focus also on what is. And when we look at the opportunities, it's not only what I was saying before. It's not just ensuring that waste that can be turned into a product, but it's also the opportunity to go beyond that and use that effort to introduce your productive capacity in the country. This year, those of you who are economists know that the Nobel Prize winner in economics, Philippe Babion, they were emphasizing two things. Growth is going to come if you have productivity. But productivity cannot be a concept in abstract, it has to be a concrete concept. The concrete concept is going to emerge to the point that companies are going to make the investment needed to move to a different step. Regularity in this particular case presents an opportunity. Again, I would invite you to download that report, Google it. This is going to have the review again of challenges, opportunities, and way ahead. Hopefully we have a good day. I think that later I come back again, but thank you very much also for the opportunity to be with you here.
Thank you again, Humberto. This was a really setting an excellent framework for opening the next remarks from our speakers. So I would like to introduce our next speaker, Özgür Osal. I hope to have the correct pronunciation. It's quite difficult with Turkey, so to be patient. From the European delegation on Turkey. He's a program manager of the European delegation in this beautiful country where he oversees innovations, competitiveness, and ESME programs. He serves as the delegation focal point for Horizon Europe, science and research cooperation, and technology and industry-oriented European initiatives. So we have the perfect link between the first words of the director of the World Bank. And now I wanted to give the floor to Mr. Osal, please.
Thank you, Rocio. This is Özgür Öcal, to pronounce it, and thank you for your presentation, introduction, sorry. Well, even though it is online, it's my pleasure to be here with you today in a key event, fostering collaboration between civil society, industry, technology, and innovation ecosystems in Turkey and Europe. As some of you already followed, we have indeed confirmed and underlined once again in the latest high level between Turkey and EU, high level dialogue between EU Turkey on technology innovation, the importance of cooperation with a focus on green and digital transformation, and of course, building thriving innovation ecosystems. We have common challenges, and looking to the future, we must recognize these common challenges such as climate change, regional barriers, regional trade barriers, global disputes. And of course, as you know, we have also sectoral challenges such as microplastics, textile pollution. So, I mean, to remain competitive, I think EU and Turkey must act and work together with other associated countries to accelerate the technological advancements. As some of you already know, Mario Draghi's latest report on EU competitiveness already emphasizes the need to foster innovation and identify new growth engines for the economy. So in parallel, it stresses addressing the high energy prices and the necessity to transition to a resource-efficient and circular economy. We need to foster deep and disruptive technologies together. Thanks to Horizon Europe, this program fosters research and innovation and plays a crucial role in addressing these challenges. I can tell you 10 years ago, when I started to deal with this technology and innovation business, Turkish research area and innovation ecosystem were suffering from low levels of participation and lack of access to essential networks to become part of the strong consortiums. I think PLASTICE is an excellent example confirming that we reverted this negative trend in Turkey through our mutual efforts, of course, with TÜBİTAK, with Ministry of Industry and Technology, and of course, with partners from Europe and Turkey. For the last 3 consecutive years, I am happy to tell you that Turkey hits an average of 100 billion euro Horizon Europe grants, together with its partners from Europe and associated countries. Turkey's increasing success in Horizon Europe demonstrates its potential as a hub for scientific excellence. I think at this point it's worth to say something about PLASTICE, this important project here. Through the collaborative efforts of all of you, the distinguished partners, the project has been contributing to resource efficiency and circular economy solutions, expanding their impact in the industry. So it's, I think, very valuable. Today's event provides an excellent platform to forge new partnership, exchange ideas, and align our efforts with Horizon Europe's strategic priorities. Therefore, I invite you to take full advantage of the event to connect, to explore, and to exchange with each other. Thank you very much for your participation, and thank you for the organizers who make this event possible today.
Thank you so much, Özgür. I think it was a perfect introduction of the current work that the European Union is doing, also in Turkey, and also the importance of this country for both of us, for PLASTICE project. Also, this is let's say, an effective and pragmatic example of what the European Union is overseeing, and also of the main, let's say, opportunities we are trying to match with the challenges, as Umberto mentioned before. So now I want to give the word to our next speaker from the private sector, from our hosting institution, textile. So I would like to introduce you to Ayşe Gümüşoğlu from textile. She's supplier management systems manager at textile with extensive experience in sustainability, social compliance, and supply chain traceability. She has supported multiple environmental and human rights due diligence processes across global value chain and contributes to the company's ambitious sustainability roadmap. So please, the floor is yours.
Good morning, everyone. My name is Ayşe Gümüşoğlu, and I am Supplier Management System Manager at Sun Textile. And I have been with company for 7 years, and mainly responsible for product traceability, social compliance, and technical compliance, environmental compliance, and environmental innovation teams. Thank you for joining us today, and thank you for coming. Let me briefly introduce my company. Sun Textile is one of the Turkey's leading garment manufacturer and exporter company, with an annual revenue to over 200 million euros, and we export 3 million units per month, and we are one of the top 500 company in Turkey. And we create around 850 designs every month for our international customers, such as Inditex, Bershka, H&M, or Primark. And actually, what defines us is sustainability-driven culture. Sun Textile has always been pioneer in sustainability in textile industry. According to our approach, sustainability is not such a compliance requirement. It's a strategic directions that shapes how we design our product, how we produce, how can we manage our supply chain. Actually, we have two main targets for the future. One of them is 100% sustainable product. And other one is reaching net zero emissions by 2040. And our all production process are planned in line these two targets. And regarding to recycling, I can say for our cutting wastage, we are working with partner company called Fazla, and for our leftover units, we have a project for donation, and some of leftover units we are working with another partner company called Reenap. And actually, for now, we have reached our 94% sustainable across our targets. And that's all. Thank you for coming.
The microphone is here so that I have to until here. So thank you so much, Ms. Eize, and also thank you for hosting us in this beautiful first workshop of PLASTICE. So now I would like to introduce also one key speaker from the civil society sector, because what we wanted to reflect also in this event, but starting from the opening, is the different perspectives we can get. So now I would like to give the word to Hecho por Nosotros representative. Unfortunately, Adriana Marina, as a last moment issue, cannot participate, but in his behalf, we will have Marisol Rodriguez that will be talking from Latin America. Please.
Hi, thank you so much. Do you hear me well?
Yes.
Thank you. I am deeply grateful, all of us are deeply grateful for this invitation, which gives us the opportunity to bring the voice of our communities and our experiences and our systemic work into a space where new materials and new technologies are being imagined. When Adriana Marina, the founder, first embarked on the creation of the NGO Hecho por Nosotros, operating side by side with Animana, she knew that she didn't want to work only as an advocate for change, just raising awareness and educating the public about the injustices in the textile industry. Instead, she knew that she wanted to work on creating concrete solutions that used market forces to solve these complex and international issues. She knew that having a business alternative that considered the long-term welfare of artisans, respected their cultural traditions, and avoided environmental degradation will be the way forward with our brand. So, since its creation, Animana has not only grown commercially, but has always sought to affect systemic change in the fashion industry with products designed under the principles of sustainability, longevity, and social responsibility. The complexity and the lack of real alternatives to the issues that Animana intends to solve leads us to realize that scaling our business model and underlying principles was the only viable solution to make a concrete and long-lasting impact. So at Hecho por Nosotros and Animana, we have dedicated more than 16 years to driving systemic change in creative economies. And we have learned that transformation is only possible when we connect cultures, knowledge, and also people. Throughout this journey, we have been co-creating solutions with artisans, producers, researchers, and also change makers across Latin America, Asia, Africa, and around the world through collaborative models that promote sustainability. So our contribution to these workshops comes from our own field of expertise, building regenerative models, strengthening value chains, and connecting ancestral knowledge with new digital tools. Through our work, we have seen how fragmented production systems create social and environmental challenges. Challenges that are very similar to those that appear in material cycles such as plastics. In our experience, circularity is not only a technical process, it is also a cultural and social one. We learn this from the communities that we work with, where ancestral practices show us how creativity, production, and nature can coexist, and how the beautiful ways they craft textile and sustain traditions reflect the profound human and cultural wisdom embedded in their work. So their wisdom is what we usually call artisanal intelligence, the living knowledge that communities hold in their hands, in their techniques, and in their relationship with the earth. It is the wisdom that teaches us how to create without destroying and how to innovate without forgetting. At the same time, we see how artificial intelligence and advanced technologies are emerging as powerful tools, but technologies can uh, only be created from what we feed into them. So for us, the question is, how can we ensure that artisanal intelligence becomes the foundation upon which new tools and new systems are built? How we can reconnect with our roots so that digital tools enhance rather than replace the ancestral capacities that humanity has cultivated for centuries? So at Hecho por Nosotros and Animana, we believe that systemic change must begin with collaboration, especially at this critical moment in our society when fragmented value chains, environmental degradation, social inequality, and disconnection threaten both people and ecosystem. So we believe that the time to act and co-create solution is now, and when we embrace collaboration and integrate artisanal intelligence with these new tools and allow ancestral wisdom to guide technological innovation, we open the door to a new paradigm, one where creativity and coexistence become the engineers of systemic transformation. So this invitation to participate in this workshop is very meaningful to us because it reflects a shared vision, the need to rethink systemic through collaboration, interdisciplinarity, and also using an holistic approach. So this is the essence of Hecho por Nosotros and Animana, that it's a commitment to ensuring that the change we want to see in the world is made by us. Thank you.
Thank you, Marisol. It's also, I think it was really special to bring into Plastice the Hecho por Nosotros experience because they started as NGO and then created as AMEs to try to reflect what they wanted to promote. And now they have no frontiers in the world to work with different organizations on research, but also on the field with artisans to include, for example, in artificial intelligence tools for facilitating the introduction of them into the regional value chains. So thank you so much for this really interesting conversation. And now we have, as last but not least, at the Dr. Clara Angela Jarauta from CIRSI Foundation. She will give us also the final words to close this opening session. I will introduce her, but basically she is one of the key persons that can also show you a little bit of what Plastice is. This is the first introduction about who we are, what is Plastice, and why we are here, basically. But also, after this opening session, we will have a more focused session on what technologies we are developing inside Plastice. So Dr. Clara Jarauta is technical coordinator at CIRSE and also Plastice and leads the waste and renewable gas valorization teams. She specializes in thermochemical and biological recycling pathways, hydrogen and biomethane production, and circular processes. So Clara, the floor is all yours.
Thank you, Rafael, and thank you everyone for being here. Because I understand it is Friday, it is really early in the rest part of Europe. So all people here, all online, welcome to our first workshop. I think it is pretty amazing. We have organized an international and European workshop. So at this point of the project, it is really, really helpful to us to understand what are the needs, the opportunities, the barriers that we need to overcome in the project. Because I think this closure of the opening session is going to be quite easy to me because you have already mentioned for me the key points we have to face and to deal with in the whole value chain, because it's just not only about innovation, that maybe Plastice is much more related to that. It is also about funding. It is also about social and environmental impact. It is also about support, regulatory development that is aligned with that. So I think it's going to be a success, and hopefully we'll have a really nice memorandum of understanding that will really support what we are facing in Plastice. So maybe you have already had a chance to check the brochure or the roll-up of the project, so I'm not going to extend too much of this. We are a Horizon Europe project, almost 20 million total cost, if I'm not wrong, of project, around 22 organizations, a little bit 23 partners in total, let's say, with, this administration things. And we are a multidisciplinary consortium. That means we are not just part of only the research part of our organizations, but we also have industries, we also have NGOs, we also have, let's say, consultancy bodies. So that gives us a really wide perspective of what is needed in the value chain. But in fact, we need further and external inputs to, to shape all what we need to develop real and potential technologies that can be further replicated and further implemented in the medium, short term, or long term in the industry. So what we are doing in PLASTICE could be, let's say, split it in two parts. One part will really focus on developing new technologies that can complement what we already have in the market. Because I mean, I'm not going to get into numbers, but all of us know we have a huge challenge in terms of plastic recycling, in terms of textile recycling. The ratios of recycling materials are not that high, and that means that maybe the current solutions, mostly mechanical solutions, are not cannot cover all the all the spectrum of materials that we are just processing in our society. So chemical recycling is how is needed. That doesn't mean that we are fighting against mechanical recycling. That's not the point. But we need to understand how both routes can be complementary between each other. So in terms of chemical recycling, you have different options. In the case of PLASTICE, we are working, let's say, with three different technological routes. One is really focused on producing liquids that can be further into fed in downstream processes to produce circular olefins. Second route is much more related to produce directly from syngas to dimethyl ether and olefins. And I'm going quite fast because that is going to be really well explained in further sessions, and I don't want to get too technical. That's something I want to avoid. And the third one is the one that is really related with the Sun Textile and other colleagues are working. It is enzymatic hydrolysis to recover PET fibers. So somehow we are quite ambitious project because we are working from quite not so mature technologies. We are aiming to upscale that, and we are aiming to develop solutions that can be further upscaled to TRL9. So, we are now 42 months old. So we are a teenager project, not really that big, but we are now seeing the potential of these technologies. Obviously, they have quite big challenges, but it is something that hopefully can be at least solved by the end of the period. That comes together with the second pillar, that is also digitalization. I think it was also mentioned by previous speaker. We need to progress with our society environment. We need to introduce artificial intelligence solutions to make the processes more efficient. We also need to improve the sorting systems because at the end, these processes need specific requirements in terms of feedstock. So if we have a mix that cannot somehow foresee the impurities or the problems that can be affect downstream, it makes even bigger the challenge. So certain systems really need to be improved and be aligned with the technology's requirements. And for sure, that is something we are working in parallel with all these type of actions. We need to understand the sectoral vision. We need to understand what market needs, because we can develop technology, but market has another requirement. So it's something we can face we are facing indeed in PLASTICE at the same time. And I think from my side it is all. We get in further details in the session, so I don't want to extend too much. Thank you for your attention.
Thank you so much, Clara. It was a brilliant close to this opening block. So fantastic. So now that we have set the overall strategic and policy context, we will move into the technological heart of PLASTICE, the 4 demo sites. These demo sites represent different recycling pathways and are essential to understanding how circularity can be implemented in practice. PLASTICE in practice. Let us begin with our first demo site presentation, which focuses on the microwave-assisted catalysis. So I would like to give the floor now to the Dr. Ignacio Murillo from CIRSE. He's a microwave technology manager at CIRSE, specializing in microwave-assisted catalysis, advanced thermal processing, and energy efficiency recycling technologies. With over 40 publications and a strong record in industrial translation, he plays a key role in circular innovation, and he will be talking about this first technology. Please.
Thank you very much, Sofia, for the nice introduction. And good morning, everyone. It's a great pleasure for me to show you the first of the demo sites that we have developed within the PLASTICE project, which is devoted to the microwave-assisted pyrolysis for mixed polyolefin waste valorization. So which is the problem that we tackle? We try to recycle in a chemical way the plastics, mix of plastics from the yellow bin, and specifically polyolefins, so polyethylene, polypropylene, and PET fractions that cannot be separated in some mechanical sorting systems. So this is the process that we carry out through this technology. So we first separate other problematic plastics from this one, so polystyrene or PVC, and then we pelletize our mixed plastic. We convert them into pyrolysis oil in our microwave-assisted pyrolysis technology. And then through catalytic cracking and repolymerization, we can produce the second generation of polyethylene. So the key points within this value chain are the mechanical treatment for the sorting and agglomeration of this initial waste. And the one that I'm gonna speak in a greater detail is the thermochemical recycling. Thermochemical recycling of plastics, of a mix of plastic, is problematic because it has a very high energy consumption. And also, it has a typically low control on oil's quality. It's difficult to control which kind of built-in block are you gonna produce out of the process. For those who are not very familiar with pyrolysis or plastics, this is a kind of polymer, so a chain of hydrocarbons and other chemical atoms. And pyrolysis, what does is to cut chemical bonds at certain points to generate valuable products out of that. So it's especially important to control this step in order to get the molecules that we want and avoid the formation of other undesired molecules. To have a better control of the thermochemical process, our innovation consists in using microwave as heating source. Microwaves are electromagnetic waves that irradiating a sample are able to heat it selectively in order to get a certain temperature and control how the molecules of the polymer are rated. So if we compare conventional heating that comes from the vessel wall to the inner sample, we have a thermal gradient that doesn't allow us to control how the process can take place. But however, using microwave-assisted heating, we get a fast, selective, and volumetric heating, and we enhance the energy efficiency, which is also very relevant for the process. Our commitment in CIRSE with the microwave-assisted technologies for the recycling and valorization of waste is very, very high. And the proof of that is that besides PLASTICE, we are participating in 6 parallel European projects for the recovery of fibers from wind turbine blades, for example, or evaluating the recyclability of bio-based composites, or also we work with construction and demolition composite waste, biomass valorization, and textile recycling, which may be the most interesting for you. In our case, we are tackling PET and polycotton recycling. But coming to PLASTICE activities, the first thing we did in the early stage of the project was the technology proof of concept. So in a quite small microwave oven unit, we started evaluating different operating conditions to get the most value out of it. So the oils that contain the exact building blocks that we need to produce this second generation polyethylene. So based on this, we were able to compare how our technology performs against conventional heating. And what we got is the 100% of the molecules that were conforming the oils were useful for the generation of secondary polyethylene. In comparison to the conventional process in which almost 10% of the fraction was not usable at all for, and it was poisoning the production of the second generation polyethylene. That was an encouraging result, and this drove us to generate a pilot plant out of it. So The reactor is the core of this system, but we have, of course, a feeding system and a post-processing system to get finally oils and waxes to be used for this second polyethylene production. It was a long journey, more than 2 years, trying to develop this pilot plant, starting from reactor modeling and simulation, process engineering, and of course the construction and assembly that led us to the commissioning of a first of a kind pilot plant in Europe, able to process up to 10 kilograms per hour of a mixture of polyethylene, polypropylene, and PET, with just 9 kilowatt power of microwave as irradiation, as a heating power, having a great energy efficiency and nice yield to oils. This plant has been protected as trade secret by our organization, and the purpose at the end of the project is to upscale this further into the waste manager plan. So this leads me to the lessons learned and the barriers. Lessons learned. The first one is that the mixed polyolefins waste is difficult to be recycled due to the complex composition. The valorization of this waste via pyrolysis is the most eco-friendly management route. The microwave-assisted pyrolysis enhances the control over the oil products distribution, minimizing the energy consumption as well. The sort of oil products by this technology is much more interesting than those obtained under conventional pyrolysis. The continuous microwave reactor concept represents the first of a kind microwave reactor design within the Europe framework for mixed polyolefins valorization. And the pilot plant was commissioned in the second quarter this year, and is currently being optimized to boost this pyrolysis oil out of this plastic mixture. Implementation barriers. The mixed polyolefin pyrolysis and repolymerization of chemical building blocks is a very energy-intensive process. So we need to found this. We need to have a regulatory frame that is convenient for the process. Otherwise, it is difficult from an economic point of view to carry it out. Despite this, the microwave-assisted pyrolysis partially decreased the energy consumption, but it's CapEx intensive. The barrier was for us in technical terms that it doesn't exist any benchmarking pilot unit for this kind of waste. So we were the first facing this issue. The polyolefin waste contamination with PVC or polystyrene, it's even more complicated. Yeah, and these two particular plastics may ruin the process performance. So the pre-sorting of the waste is important. We have a dilemma whether to install the recycling facility at the waste manager or at the end user side, because either waste bales or the raw oils obtained out of the recycling mechanism would need to be transported. And another big barrier is the process scale, because the pyrolysis throughput is delocalized and not sufficient to feed the macro-stream cracking facilities on a regular basis, and not even enough to reach the 5% feeding goals that are instead at European level. So finally, I want to thank all the organizations involved in this development: TIRFE, my home institution, Azcatec, Urbacer, and Total Energies. Thank you very much for your attention.
Thank you so much, Ignacio. It was really interesting. I really like the final slide with the. So now I would like to give the word to our next speaker. I hope to pronounce it very well. Today is not my daily names. I get it. So Etienne is a PhD researcher in the catalyst engineering group at the University of Amsterdam. He focuses on hydrothermal liquefaction, advanced catalytic systems, and chemical recycling of plastics into circular fixtures. And he will introduce all of our technologies. So please, the floor is yours.
Thank you for the introduction and everyone. So I'm going to introduce another technology that also similar to pyrolysis. We try to break down the waste plastics into oil, and the technology here is called hydrothermal liquefaction, and we call it HTL in abbreviation. So similarly, the waste that we are dealing with is the plastics. And here's the figures that in the row, right now, that we have 350 million tons of plastic waste per year. And among them, 9% are actually recycled right now, and 22% are mismanaged or littered, 19% incinerated, and 49% landfill. And so there's only 9% recycled. That is the mechanical recycling technology that we are mostly using for recycling right now. And the part that we really want to deal with in plastics, at least for the plastic recycling part, is the one that are actually collected in our system already. But right now, they are either incinerated or landfill. And so these plastics, they are collected but not recycled. And then the reason of this is because they are either a mixture of different plastic types, so it's not easy to be mechanical recycled, or there are contamination by the maybe food waste or the detergent waste that was the residue inside the plastics. That is the nature of the municipal waste that we collected. And also the colorant and additive that is embedded in the plastic material itself. So it's also impossible to remove. And also there are the water contents everywhere. That is also the nature of the plastic waste that we collected. And yes, this is the plastic waste that we are dealing with. So similar to the pyrolysis one, so we cooperate with the OGRSA. It is a municipal waste management company, and they separate the plastic waste into like very different kind of batches. And these are the three types, and right now we are mostly focused on doing the recycling. The first one is the HDPE, another one is more rich in LDPE, and the last one is called solid recovered fuel, which is only around 50% of LDPE inside. And these are the plastic waste that right now they can try to separate, but into the stream that is still not very pure, and then cannot be mechanical recycled. And we are trying to do the chemical recycling way to deal with it. And here is the introduction of the HTO, how HTO works. So the major different compared to pyrolysis is that we put water inside the reaction. So we put water and plastic waste into a reactor, and we also heat up to high temperature, around 430, 450 degrees, and the high pressure is around 200 bar, which is around 200 times of the atmospheric pressure. And the reaction goes along around 30 to 60 minutes. And the plastic will be break down into either gas, oil, or some char residue. And the water can be recovered. And the oil part, we want to be spin crack it into the monomers, and which can be made into new plastics and then into new plastic products. And here's a brief results of the three plastic waste that been HTL. So the major thing I want to mention is that like in the HDPE, there are 98% of PEPP, and LDPE, there are 90% of the PEPP, and SRF, there are around 54% PE and PP. And the results show that the bottom right part, the oil yield of the HDPE can reach around 80%, and the LDPE can reach around 60%, and SRF around 40 to 50%. And I also done a virgin PE just to compare. So like the virgin PE can get also 85%, and then without any char residue, which is the part that is the most invaluable among these three products. And so we can see that the residue part is actually quite correlated to the feedstock itself. So the waste that if it's more clean with plastic, we can still get more oil out of it. And that is the basic result that we find. And this is in a lab scale, which is around 500 milliliter. And right now we are building a pilot scale reactor, which is in a 25 liter scale. And Yeah, this is the design of the pilot scale reactor. So basically the reactor is here, and then there will be other two storing and then touch pot for the after we do the reactions. And it's already being built in many parts, and right now it's still doing the assembly part, and then it's scheduled to finish in next month, and we will try out in next year to see how it actually works. And here, the lesson learned from building the pilot reactor is that there are some process that we are like quite new to it. So like, for example, parts of study that we actually we need to do some design change, and there will be the assessment by notifying body that which is the requirement of EU, that it will be taking some more time than we expected. And also the material procurement timeline is also that what we need to really focus on, especially for there are some special materials that require in this special high pressure, high temperature reactor. And also this because of this reactor special design, they also have the difficulty in machining for the compared with the other normal reactors. And finally, we also do a technological and economics assessment for the passive waste later on in actually running in a commercial scale, which is 200 tons per day. And so here the process is quite similar. The major difference is that we couple the HTO reactor with a steam cracker, which is directly can break down the oil into polyethylene or propylene or ethylene, which is the monomer of the new plastics. And we see that we can have ethylene output of 111 tons per day, propylene output around 60 tons per day, and the overall energy efficiency can be 77%. And the capex has been 159 million euros, which is quite a lot. And compared to other recycling technology, but the OPEX is 43 million per year. And the return of investment, 10%, payback period 2.5 years. So based on the calculation, it's actually in a large scale, it would be possible to actually work in this recycling system. Yeah. So that's all for my side. Thank you.
Thank you so much. Now, I would like to give the word to the next speaker. So I will introduce you to Eros Luciano Paracci. He's an engineer with more than 25 years of experience in metallurgy, steelmaking, hydrogen-based decarbonization, and industrial R&D. And he has coordinated international innovation projects linked heavy industry and advanced material science. He will be here representing one of the organizations that are also part of the consortium, RINA, Centro Gruppo Materiali, that is the Center of Material Development in English. And he will talk specifically about this other technology. So, Eros, please, the floor is yours.
Good morning to everyone. Again, I'll show you a very brief presentation about another pilot demo plant that is developing into the PLASTICE project. Okay. Okay, very helicopter overview because this type of project, this type of plant is very complex, but I don't want to give you a very precise description, but just I give you an overview, very comprehensive overview. This is the partner of the project because, of course, is the construction, the design, construction of this type of plant request the capability, the skill of different companies. This is the report in this slide. There are the waste provider, of course, that is provided the plastic residue that want to be recycled. We have chemical empowering and CSM as technology provided, as also CNR. And also we have Tier 2B as a DME validator in order to qualify the product that will be obtained for this type of plant. We, of course, in order to realize this type of plant, we started with a preliminary activity because we have to test the capability of this process to convert the plastic into the final product, that is the DME. we realized some small experimental trial in our premises and also in other premises to verify that this is the best process condition. So let's move to the material that we will treat. This is the secondary use fuel that is composed of different type of plastic. In order to verify the capability to transform this material into the final product, is the olefin, we realized that the first experimental test into our premises. This is a small reactor. This is reported here. Is a rotary kiln reactor where we transform this type of material, the secondary use fuel, into the syngas. The syngas is a product that comes from the gasification of this type of material, and is mainly composed of CO, nitrogen, hydrogen, and so on. This is the picture. Okay, this is the okay, this is the reactor, and this is the scheme of the reactor that we have. Of course, before to start the experimental trial, we realized some kind of model to verify that it works properly. This is the structure of the model that we obtained in order to give an idea of the best process condition to realize the optimal syngas composition. This is the result that we obtained in terms of mass balance and energy balance. The parameter of this model has been set up after the test that we performed into the rotary kiln reactor in a small scale that we realized. Let's move to the second part. This is the gasification part. Let's move in the second part of this process, is the catalytic conversion, because we obtain the syngas, but we have to transform this syngas into the olefin. This process occurs through the utilization of two different types of catalysts. The basic idea is to transform this syngas into this DME and then in olefins through one single reactor, not passed through the intermediate process, that is methanol, but directly from syngas to DME. This is the second approach. This is reported below, the PLASTICE approach. Also, in these cases, we just performed the activity at lab scale. This is performed by CNR, where they tested the efficiency, the selectivity of the catalyst. And during these phases, various types of catalysts has been tested. Here you can see one example, and this is the idea of the conversion, capability conversion of the catalyst, the result obtained in lab scale test. This is for DME catalyst, and this is for the transformation of the DME into the olefins. Also, in these cases, we tested into this work package, we tested some the efficiency and the selectivity of the catalyst. Let's move to the we also performed the first test has been performed in a very, very small scale. Then we also performed the capability of the catalyst in a larger scale. This is the test we performed in our premises. In these cases, we use an autoclave that is able to reach 50 bar pressure at the temperature. And this is the condition in which the catalyst has been tested. Now let's move after all this preparatory activity. We are almost, and we obtain the result, we are almost ready to collect all the information and to start the design, started before the construction of the plant. This is some figures about the plant. The size of the plant is quite large because this plant is able, demo plant is able to treat about 1.5 tons of material 4 hours. And the main component are reported here, the list. This is the rotary kiln reactor, gasifier. This is the plasma reactor to remove the ashes that is contained in the syngas. There is some other part that is to clean the gas. And then there are the zeolitic and dry bed reactor, water separated distillation column that permit to obtain, to clean the gas in order to obtain the final product. Let's move with the component of the plant that are some picture. This is the sides of the gasifier. This is the torch, this is maybe the more important part of the reactor. That is this part one. This part is the geolithium nitride bed reactor. It uses this reactor as put in parallel, and it permits to separate the syngas through the water and the DME through a semi-permeable membrane. The process can be schematized in the next slide. Okay, that's one, the process flow. So we have the syngas, we have the geolithium nitride bed reactor, where we obtained a mixture between composed by syngas, DME, water, and methanol. We have a system to separate the main component. Of course, the methanol and the water that are byproduct of this reactor are recycled, and the syngas and the DMA are sent to another separator to obtain the syngas from one side and the DMA for another side. We not finish the transformation because we have to transform the DMA in another product, the olefins, and in this case we use another reactor that works at room temperature and room pressure, and that permit, with another catalyst, that permit to convert DMA into the olefins. So this is the main figures of the plant that I quote before. So we think to obtain it about per hour. This is about 6 or less than 700 kilogram per hour olefins. The energy consumption is about less than 1 megawatt. It's about 700 of kilowatt, and estimated energy is about the cost in euro, but it depends on the states and the market. It's about 0.35 euro per kilowatt. So this is my last slide, of course, but I want to conclude this presentation with the lesson that we learned from the realization of this plant. And of course, we learned something, of course, because the realization of the plant of such size required a lot of preliminary steps. This is very important, not only from a technical point of view, but also from a normative point of view, because the construction, the exploitation of the experimental trial need the rule and also the authorization for the local authority. And so it's necessary to start as soon as possible because the time, mainly in Italy, but I think not in other countries, quite long. And also it's important to start with the commissioning and also the procurement of the component of the plant as soon as possible in order to arrive at the construction of the plant in time. I think that is okay. This is the last one. Thank you very much for your attention.
Thank you so much. It was really interesting. And as you said, a quick intervention. So thank you so much. So now we have the last technology, but not for this, the least. Virtually, it's joining us Barbara Lill, the next speaker from TCKT, Austria. She's project manager and researcher with expertise in polymer, biopolymer, and biocomposite recycling. She holds a master in chemistry and materials technology and supports the development of advanced recycling materials for industry. So now, with her introduction, Barbara, please, the floor is yours. And just a quick reminder to all the virtual speakers joining today, for technical pragmaticity, I will ask you to share directly the screen on Teams. Thank you so much. Please.
Hello from online. Can you hear me and also see my screen now?
Yeah, we can hear you and see the screen now. Thank you.
Okay, perfect. Yeah, I'm sorry not to be able to join in person today, but anyhow, yeah, I will tell you something about the cascade enzymatic hydrolysis from online. And this technology is a green approach to separate waste streams for recycling. I'm starting with the current state of textile recycling, which is the motivation behind our technology. So yeah, 5.8 million tons of textile waste are thrown away by consumers every year in the EU alone. And the vast majority of this waste is landfilled or incinerated. And only 25% of textiles are expected to be reused or recycled worldwide, which is, yeah, not quite a lot. And even less is the 1% of textile waste that is made into textiles again. So what is the problem and why are these numbers so low? One reason is that in clothing, fibers are mixed to achieve different properties such as wearing comfort or crease resistance, washing properties, and so on. And in recycling, the problem is that mixtures make it very difficult. So our technology, the enzymatic hydrolysis, is a green approach to separate cotton and polyester mixed textiles and enable a mechanical recycling of the polyester fibers from clothing waste. This is now the overall concept. So we start on the left side with our textile waste, which is then sorted to cotton polyester textiles, which we target with our technology. And all the other textiles are rejected for the moment. Then we have to separate metals and hard parts like, yeah, the clothings usually have like buttons and zippers and that stuff from the actual fabrics. And the fabrics that are left then are pre-treated in several ways. So we apply chemical pre-treatment and we also shred the textiles to smaller pieces. And this shredded textile waste is then used for the enzymatic hydrolysis. And the outcome after this process that I will explain in the next slide a bit more in detail is some short polyester fibers that can then go to plastics recycling and after several steps be made into polyester fibers again. And the other outcome is a sugar solution, which also can further be processed to ethanol or other biochemical products and can further be reused. So I will explain the process a bit more in detail. So we start with our input material, which I already mentioned is a mixed textile waste made of cotton and polyester fibers. We can take a closer look at this. So I made it in purple. This is the cotton fibers, and the yellow lines should represent the polyester fibers. We then make a pre-treatment, the chemical pre-treatment and the shredding, and the enzymatic hydrolysis process on these textiles. We apply enzymes for this process, and enzymes are biochemical catalysts that specifically target a chemical reaction. And in our case, this is the splitting of the cotton chains to glucose molecules. So we have our PET fibers and the glucose left in our containments after the reaction time of this enzymatic hydrolysis. We then further process by separating the PET fibers from the glucose solution, which is quite easy by just filtering them off. So this is the actual underlying enzymatic hydrolysis process. Then these PET fibers can further be processed in a thermomechanical recycling process to granules again. These granules can be used to spin yarns again, and from these yarns we can produce recycled fabric and a clothing again. So in PLASTICE, the main objective of our technology is to develop and validate a pilot plant of this enzymatic recycling process for the mixed cotton and polyester textiles. And this should be achieved by several steps, which are the sorting as the first step. So we have to enable a sorting to sort out the appropriate textile waste streams for our technology. Then we need to assess the appropriate operational conditions, first in lab scale, and further scale up the process and develop a pilot plant for the enzymatic recycling. And finally, our last goal is to demonstrate the recycling process in pilot scale and validate the outcome. So what have we already achieved with our technology to date? The first advance is that we managed the sorting of the target textile waste stream at pilot scale, and we sorted out a total of several hundreds of kilograms of the targeted cotton polyester textiles. We upscaled our enzymatic hydrolysis process gradually. So we started from lab scale with several milliliters to now small pilot scale, which is over 100 liters. And our small pilot reactor is successfully implemented now and in operation. And we also made an advance in materials complexity stepwise from rather easy materials, which are single sourced undyed production waste, which is quite a nice material to work with, and then moving over to more challenging materials and ending up with the most challenging material, which is real end of life post-consumer mixed textiles. And in PLASTICE, we've already been able to demonstrate full recycling trial of a very basic material, but anyhow, 100% polyester textile from production waste. And we've already demonstrated, as you can see in the pictures below, that we can make a closed recycling cycle from fabric over granules to fibers and yarns to fabric again. So the challenges and lessons learned so far are that a precise sorting of the mixed textiles is really crucial to identify the targeted waste stream and minimize contaminations with other fibers, which could be a hindrance in the subsequent recycling process. Then we've also seen that a complete turnover of the cotton to sugar is essential for the high granule quality in order to enable a fiber spinning of the granules. And we've also seen that upscaling of the recycling technology to industrial scale is expected from our experiences so far to be conceivable. And the most challenging material, the end-of-life textiles, are a quite heterogeneous waste stream, and they contain various contaminations like application of dyes, which also make the recycling even more challenging. We've several partners involved in this technology, and thank you.
So much, Barbara. Really, really, really nice presentation, and it was really nice to see all the steps on this technology. So now we finish with this showcase of demo-site technologies, and we will go for a short break. But before allowing you, to the people in presence, to go behind a good Turkish coffee, and also the people virtually to rest a little bit, I invite you to start to do questions on the chat, but also here for the formal chat with a coffee pen, with all the PLASTICE members, that we are all here to assist you and resolve any questions you may have for these technologies of our project in general, and maybe find new things to cooperate or maybe opportunities to work together on. Also, a quick reminder for everyone, in our website, you can reach all the publications we have made alongside the project. So there also you have more results and more insights and more about what is PLASTICE. Thank you so much, and we are coming back in 15 minutes. Welcome back, everyone online in presence. I hope you have enjoyed the really good biscuits they have there. I love them. They're really good. And also the Turkish coffee, that was an amazing discovery I made, and really, really good. So I hope you have a refreshing break. And now, with our PLASTICE colleagues, we will come back to the next block of the agenda. And for that, I would like to give now the moderator role to my colleague Remy Kelkin. He is a senior researcher at Centerberg, Bellevue, the leading research center for textiles and plastics, and specialist in sustainable textiles, advanced scientific technologies, and innovative recycling. Remy reached scientific research and industrial implementation, and now he will be leading this talk. Thank you so much. Please.
And thank you for asking me to be the moderator of the session. So we now enter the on-focus session where we will take a closer look at key technological aspects, sustainability, and policy aspects. And look, we'll bring together industrial leaders. We add the speaker now. Okay, so please, if you are a speaker of this session, I will ask you to come and sit on stage.
Please, Umberto, Gotze, Jan, and Onur, if you can join the scenario, please. As you prefer, it's okay. Jan,
It's online.
yeah.
I will attend online.
It's online, all the rest are online. Okay, you can see that.
Okay, but I don't mind. Thank you. So I will continue. So this blog brings together industrial leaders, R&D organization, and some PLASTICE partners, offering a multi-phase view of the challenge and opportunity ahead. So to open this session, it is my pleasure to introduce you Dr. Jan Suelte-Meyer. We will bring the global industry perspective and set the technical direction for our discussion. So I think that Jan is online.
Yeah.
Dr. Jan Suelte-Meyer is global sustainability leader at Evian with 20+ years of experience across BASF, CIBA, Clariant, and Evian. He brings expertise in material innovation, corporate sustainability, and international circularity strategies. He previously co-chaired the Design for Circularity initiative at the Alliance to End Plastic Waste. So please, Jan, you can share your screen and present.
People online, can you hear us?
Yes, we can hear you.
Sorry about that. So we will jump directly to you, Umberto. So we give now the floor to the World Bank in Turkey, and it's my pleasure to welcome you.
No, thank you again. I was really impressed by the previous speakers. I have to recognize that I managed to understand just a few words of what they were saying, and when they were putting all together, I was struggling to understand what it meant. No? So let me pivot from the technical side a little bit to more the policy side. No? And I have a couple of reflections here. No? The first one is the World Bank has, as I was mentioning before, we have a program dealing with circularity, mainly on the water sector. There are reasons related to recycling, but there is also an additional reason that is particularly important. This year, this hydrological year, the hydrological year starts on October 1st, has been the year the lowest ever recorded rain in Turkey. So, that's a particular issue. And this year has also been the year with the highest ever recorded temperature in Turkey. It was
50.5 degrees Celsius in the south in July. So when you combine these two things, limited rainfall and high temperatures, you have a significant water problem. But in Izmir, there have been water restrictions. In Ankara, we are going through water restriction. What we have been trying is with the government basically to come with programs that are going to be look at the efficiency of water systems, but also with programs that basically emphasize the recycling in water. You don't need it for irrigation. You can use recycled water rather than use clean water. So this is one of the issues. Now, the second reflection, I don't know whether it's a reflection or is more a question regards the textile that is related to the questions that to the session now. And these days, when we're talking about textile industry in Turkey, are not the wind is not going. You are not going with the wind. You are going against the wind. There are plenty of textile companies that have stopped doing business in Turkey. We can discuss that. There are a good number of reasons for that, but the fact is that the textile industry is having a difficult moment. So when we are talking about some of the technology that is behind recycling, to what extent this is going to be an opportunity for the textile industry, or to what extent this is going to be a little bit pie in the sky because the textile industry is not going to be able to bring this to a table. And this is something that we need to discuss as well, because we can have all the systems of the processes in place, but if it doesn't make sense from an economic point of view, then you have a problem also, because nobody is going to adapt that. And this is what I was mentioning before, that when you look at these issues, you need to bring regulatory framework, the private sector, consumers. And when you are talking about the private sector, you want also to consider two parts: those that recycle and those that use inputs that can be recycled, use it as recycling. No? So this is something that is particularly important. And again, it's not that I have a clear answer. Mine is more of a question for that. It was the head of Toyota many years ago that used to say, never waste a good crisis. And I think that this is something that perhaps the textile industry, and again, I would like to hear about that, but perhaps the textile industry can come with ideas where, even if you are having a difficult moment now, you can look at recycling not as an additional burden, but basically as something that is going to help you to create a brand for Turkey. How can you ensure that when you are going to be selling a product, you can have a component, a high component of recyclable goods there? Because as I was mentioning before, one of my daughters refused to buy anything if it's not recycled, or something like that. Probably this is not going to happen with people my age. I want to be candid. I'm pretty sure that you have a good number of, she will get upset if I said, a good number of kids that are going to be willing to go into that direction. So this is what I wanted to put on the table once again, is all the techniques, all the processes, all the procedures, fine with me. The industrial processes have to be there, because if you cannot do it, of course you will never do it. But even if you can do it technically, does it make sense from a business perspective? And if it does not, how we are going to ensure that it does make sense? So this is, I think, that what I want to put on the table, because once again, in addition to the environmental sustainability, we need to think
financial sustainability of many. Thank you.
Thank you, Umberto, and I really appreciate that coming from the research side, because we don't often think about that. But after that, we need a business plan, and it has to go into business. Sometimes we restrict ourselves to only research. So that's really interesting to remind us that we need to see further.
It's also very interesting to remind me also that there is a technical part, which technically I never.
But we complete each other. Thank you very much. So we move on now to our colleague from PLASTICE, Onu Chelen, from Cortex, who will guide us through cutting-edge polymer innovation and particular applications at industry scale. So, Onu Chelen is Deputy Manager of the R&D Center at Cortex with a PhD in polymer material engineering. He leads Horizon project and To Be Tech project on innovation fibers, polymer engineering, and industrial scale circular application. Onu, the floor is yours.
Thank you for the introduction. Hello, everybody. My name is Onur Çenet. I'm the R&D Center Deputy Manager of Cortex. It's a pleasure for me to be involved in this beautiful workshop. Today, I will briefly talk about Cortex polymer recycling facilities. We created a recycled polyester yarn brand as Touch Reborn, and our motto is today for tomorrow. And we invested in a polymer recycling plant in 2021. We enable textile recycling by integrating recycled post-industrial PET bottle flakes and also pre-industrial polyester yarn waste to have a closed loop system. Our approach focuses on material traceability, quality assurance, and collaborative value chain engagement. Through advanced filtration and thermomechanical processing techniques, we maintain yarn performance with reducing raw material consumption. We have about 6,000 tons per year capacity now, but we have enough infrastructure to double up our capacity. And when we look at our location, the location is very close to our main polyester filament yarn production plant. It's a walk distance. And as I mentioned, we use PET bottle flakes and or yarn waste as a feedstock. We gain in natural resources and contribute to circular economy by using our own yarn waste. And our Touch Reborn yarn has certified by global recycle standard. Our aim expect to expand our thermomechanical recycling facilities and diverse our recycled yarn portfolio across the multiple textile applications. And we had managed some life cycle assessments, and we find out that we use less percentage water consumption, 50% less energy consumption, resulting in 30% less greenhouse gas emissions. And also, we analyze the carbon footprint in detail in an independent environmental product declaration system. Everyone can access to our detailed carbon footprint data in the given address of internet. Okay. And there is a dope dyeing technology. It doesn't use any water consumption. We add the pigments, dye pigments in the production. So it's a very environmentally friendly way of dyeing. Also, we applied this dope dyeing technology to our recycled yarn. There are some beneficials of this. Some of them are in dope dyeing, we can create our in-house tailor-made recipes according to the customer demands. Also, we have got a fast and flexible production by using our small pilot machines. And the other advantage is that the output yarn has better fastness values. But the main unique property is that it doesn't use any water, and also its color stability is much better than the fabric dyeing or bobbin dyeing. That's why the high value added textile companies like automotive textile brands prefer to use the dog type colored yarn. And the sector collaboration connects the manufacturers, brands, policymakers, and scientific centers. The goal of these are to collaborate in a circularity to enhance the certification, certification and infrastructure investments to collectively speed up the circularity adoption in the textile industry. And that's all from my side. Thank you for your attendance.
Now is the moment to give the floor to our sister project, Penguin. And it's my pleasure to introduce you Iona Muntean from this European project, Penguin. Is Iona? Are you there? Okay, perfect.
Yes, good morning.
Iona Muntean is an environmental sustainability engineer at FINA, specializing in LCA, eco-design, climate proofing, and EU sustainability regulations. She coordinates environmental work packages in EU-funded and industrial projects. So please, Iona, the floor is yours.
Yes, thank you. Let me share my screen. Just let me know if you see my presentation on full screen mode. And if you hear me well, proper.
Yes.
Okay. Thank you very much. Allow me to introduce myself. My name is Iona Muntean. I have been working in the past 2.5 years in RINA Consulting as a sustainability consulting. And it's my pleasure and honor to be here today talking in this panel of discussion on enable textile recycling horizons and introduce to you the Penguin project and explain how can material and product innovation unlock the full potential of textile recycling for the next generation outdoor apparel. Penguin project, it's a bio-inspired and advanced fiber and materials for sustainable outdoor design with biomimetic functionalities. It's a EU-funded project with a budget of 6 million euros from European Commission contribution, and our coordinator is VTT, Technical Research Center of Finland. We have 10 partners in our consortium. We have a consortium coverage that goes from the upstream textile value chain, but also we have organization as technology centers and consulting organization and NGOs that are supporting the upstream textile value chain in developing sustainable garments. Penguin basically develops sustainable and high-performing cellulose-based material for the outdoor textile market. We are driving inspiration from penguins, as the project will produce outdoor jacket prototypes using the developed textile materials that mimic the way penguins are protected from the cold and moist environment. We are covering all the upstream textile value chain in the project. And yeah, our methodology is straightforward when it comes to the upstream textile value chain, because we starting from the fiber development through insulation material and fabric production to the final product. But we have also companies that truly enhance our approach in work packages and activities that are dedicated to enhance sustainability and recyclability through the entire process. So from computational techniques and safe and sustainable by design principle that we are applying in our project through the life cycle costing or the reuse and recycling strategy, we are truly adding additional layers of sustainability to the final product that we are developing. And basically, each work package adds additional environmental responsibility. So we are trying to move from the synthetic to nature-inspired cellulose-based layer. So basically the project replace conventional petroleum-based multi-material system that are typically composed of up to 6 synthetic layers. So we have multi-materials that are difficult to recycle, and we want to substitute this with innovative cellulose-based textile structures and that are designed for circularity. And these new layers are designed to deliver equivalent thermal and functional performances while enable recyclability, biodegradability, and overall circularity. This is our strategy. It's a circular strategy to approach the outdoor textile sustainability, because starting from the material development and production, where we are applying life cycle thinking approach through the life cycle assessment, life cycle costing, and social life cycle assessment, so covering the 3 dimensions, the 3 pillars of the sustainability, the environmental, the economic, and the social part. And we are also applying the safe and sustainable by design principle to guide material and product development. As you may know, safe and sustainable by design, it's the latest EU framework meant to ensure that all chemicals and materials that we are developing are safe and sustainable. And then moving to the testing and designing and prototyping phase, we are, for instance, having the smart heating elements that we are designing. There are heating elements that will be inserted in the jacket to offer thermal comfort, and those heating elements are designed for disassembly, repair, and they are meant to give extended product lifetime. For instance, we are considering the lifetime of the battery and the lifetime of the heating element, and we are trying to put the battery in a place where it's easy to substitute in order to not shorten the lifetime of the product. Then we will have this reuse and recycling strategy, and we will calculate a circularity index, and we will use repair and reuse protocol to extend the service life of the jacket, because as you all know, recycling needs to be considered as the latest option. So we are considering the pyramid of the 4 R's or the 5 R's in the end of life strategy of the product. And finally, we are studying advanced recycling processes as mechanical, chemical, or enzymatic recycling to recover high-quality fibers and to enable the biodegradability assessment and close the loop. And this is basically our strategy in Penguin project, and our objective is to get a fully recyclable outdoor jacket. Some key lessons from our Penguin project are the following: nature-inspired design, drives sustainable innovation. Biomimicry can unlock high performance materials while reducing environmental impact. Cellulose is an incredible alternative to synthetics. It's a simplified monomaterial that can replace complex syntax system without compromising the functionality. And for sure, this type of material enable the recyclability. Circularity must start at the design stage. The safe and sustainable by design, the life cycle thinking approach, the design for recycling principle are essential foundations in designing, not optional. Integrating material, product, and process innovation, so testing, prototyping, and recycling processes development must evolve together to ensure real circular performance. And smart feature can support circularity because designing heating elements and components for disassembly and repair extend the product lifetime and simplify the end-of-life management. I will conclude my presentation leaving the following messages. Recycling succeeds only when the entire textile value chain moves together, focusing from design to end of life. Circularity is somehow a shared responsibility, and no single actor can achieve this goal alone. Thank you very much for your attention.
Presenting us another project and giving us maybe new ideas. So we will give now the word to Zoltex with Götze Zachma.
Just like my hands.
So you are an R&D specialist and a PhD researcher at Zoltex with expertise in smart textiles, process automation, and microfiber reduction technology. You have contributed to multiple Horizon Europe projects. Please.
Thank you. Hello, everyone. My name is Gökçe, and I'm an R&D engineer in Zoltex Textile. Also, I'm a PhD student in Istanbul Technical University. Today, I'm going to talk about our sustainability development projects and processes in the Zoltex Textile. First of all, Zoltex is one of the leader home textile production integrated production facility. And we have a dream of a better future. We call it Smart Life. And with Smart Life, we are aiming to reach sustainable development goals. In different projects, we try to aim different sustainable development goals, basically. With Smart Life, it's a framework, and we have divided it into first one is regenerative business models. We aim to create a carbon neutrality and circularity in our environment, in our work model. And the second section is the human-centric ecosystems. It includes inclusion and diversity. And we have some sustainability commitments in our facility. And for recycled textiles, we use GRS and RCS too. As I can say, we are not a polymer producer facility. That is why we cannot create directly a recycled product, but we can use it in recycled products in our facility as a raw material, or we can transfer it to the waste management centers, and we can use it in the different European Union or TÜBİTAK projects or other projects too. And in our R&D facility, you can see some numbers from us, and most of the projects of us is about sustainability and digital transformation. And we have completed 3 successful European Union Horizon projects. Also, we are on some new stages of the new projects. This project is also about sustainability. In our R&D center, we will most of the time work on sustainable development goals, as I mentioned before. And first one is Reclaim. Reclaim is not directly a recycled project, but it's a refurbishment and remanufacturing project, and try to minimize the waste and try to use the equipments again and again. And with this, we try to create a circular economy approach. And with Reclaim, it is a successful European Union project. And increasing production efficiency, environmental recovery efficiency, and reuse of production equipment and extension of a lifetime was a goal in this project. And our other new close Horizon project was OxyPro. In OxyPro, we try to use enzymes as a textile substances and textile chemicals because those are very polluting our water systems, and that is why it creates a lot of problem for our future, for our nature too. And basically, it's mainly about using enzymes as a chemicals. And thank you for listening.
Okay, thank you very much, Gertrude. We will directly go to the questions. And maybe I will first take questions in the room, and if we have online questions also, don't hesitate to ask. Is there any questions?
Thank you to all the speakers. It's a very interesting topic that we're covering today. I just have a question about all the recycling technologies that you've presented for textiles. Which one do you think has the most potential at this stage? Based on what you know at the moment, you're during the advancement of the front.
Maybe I can answer first.
Sure, I can. I can tell you that.
It started with mechanical cycling, but it was a long cycle recycling. So it didn't prefer so much. Then in 2000, after 2010, it became thermomechanical recycling as we do in Cortex. But with Horizon projects, we are searching for the feasibility of enzymatic recycling and chemical recycling techniques. That's why we are involved in these projects. I believe enzymatic recycling and chemical recycling will further enhance and will take the major part.
For my side, I believe my projects in European Union Horizon projects, Reclaim is not, as I mentioned before, a recycle project, but a circular economy project. That is why I believe the Reclaim will be most beneficial. Not the OxyPro one. OxyPro is a perfect project, by the way, but it's a research and innovation action level. That is why I'm not fully sure about that it is applicable to the industrial side and size too. But for Reclaim, actually, it's a very detailed project, and it is directly about automation and eliminating the operators' negative impact, and it creates directly less waste fabric and correlatively less waste of need for places to manage this waste, plastic fabrics, polyester fabrics. So I believe the Reclaim will be the most beneficial one to minimize the waste, so directly the recycling process. But from the creating the waste side, it's
I have a question because you mentioned that the textile sector is facing now some challenges. I don't know if only at national level, let's say, or also at European level. I would appreciate if you could elaborate that a little bit more, because I don't know if it's something that is happening in terms of regulation, or it is also had an impact in potential technologies to be implemented in the sector. So maybe that's, I don't know if the rest has the same curiosity, but I would like to hear a little bit.
It's a question related probably to the competitiveness of different countries, no? And with the high inflation that Turkey has been suffered since 2022, and the efforts to bring down inflation, what you had, it was a real exchange rate appreciation. And what this was doing is to negatively affect the competitiveness of the country. if you had a sector with extremely high productivity, you could compensate, you offset. But traditionally, textiles have not been a sector with really high productivity. So basically what this was doing is eroding profits. Indeed, some of the firms now are moving, some of the Turkish firms now are moving to Egypt, where they are finding, I mean, they are more productive, which means in this particular context that they are facing a situation with lower salaries. No? So that is the one of the challenges that you have. Is the particular case in Turkey where all this discussion is where make me wonder, is this going to help making firms more productive? Or if not more productive, is this going to add value added? Can you sell the same product that is recycled for an additional price? Because you are going to have people that are going to be conscious and are willing to pay more because of that. That is a question that I don't have an answer to that, but I think that it would be important that all of you that are working on these elements reach to the companies to try to understand where from a marketing point of view that there is that possibility.
I have a question, if I can. I think that one of the matching or blending points between the different speakers we have now, I'm sorry for the technical issues we are having with Abby and Asia for not participation. We will try to arrange this in other moments of the day. We're talking about, okay, we're government that work with governments, basically, that they addresses these kind of problems that are coming from civil society, but also from companies. Then the companies that are having problems in terms of, okay, how I become more sustainable, how I do this material, do more efficient, not in terms of energy only, but also in terms of cost. And I think that one of the points that maybe could be interesting to see what you have to say about is, okay, we're talking about regulation. We need to be compliant with regulation to enter to the European market. But one of the biggest problems, in addition to update and harmonize regulations inside one country or one specific level of the government, is also implementation. There is when we have the main bottlenecks. So if you can mention some experiences, challenges you have also in that, and if you succeed to address this, maybe with key conversations with the government on how a good practice, a good advice, or something to share to the audience, I think it could be really interesting to start to talk in these terms. So thank you.
Yes, there are regulations like global recycle standard or the Turkish regulations, but for the implementation, yes, you are right. It's not done very well. And also there is a tricky issue in recycling, what we observe in industrial scale. As you know, you cannot find out the recycling ratio in the recycled yarns. This is the challenge part. And also you cannot define if it is coming from textile to textile recycling. There is a very big gap. So some of the companies make some trickies. They put, for example, less recycle and blend it with the virgin polyester, then they sell it. So we have to overcome this problem. The main problem what we observe is that it's the traceability of the recycled products.
Will be the same, actually be similar, because when we weave iron or knit iron or different textile formation techniques, yes, you can say basically it is 50% recycled yarn or something else, but traceability again can be a problem in textile. exact amount, not so precise, actually. Yes.
When you are going to introduce new regulation, what you are going to have to look is at what is the cost of the regulation, what are the benefits. And some of these benefits are not going to be tangible. Some of these benefits are going to be measured in terms of sustainability, and you will need to monetize. So what is important when you are going to be looking at these things is cost is this, benefits are this. To the extent that you have benefits that are higher, in some cases you will have to convince the public that there is a benefit in the form of an externality that you are not paying, but clearly looking ahead is something that is going to be there. And this is where many times we have challenges. No? I mean, the typical case is not exactly the same, but talking about sustainability, the price of a liter of gasoline, you know what it is, and it's related to the price of a barrel of oil and the refining. But if you look at the externalities, the price would be much higher. Is the population willing to pay that price in the market because this is having a negative impact on the planet, on greenhouse, etc., etc.? If we look at the different countries, the answer is no. This is unfortunate. Let's be clear. But this is a problem that we clearly have with many of these issues.
As I mentioned before, different sustainability standards and recycled standards. With these standards, of course, you can trace the amount of the recycled amount in the total yarn. It is possible, but it is fine that sometimes it's maybe tricky.
Thank you so much.
Okay. Do we have a question from online?
Any questions from?
Yeah.
Yeah.
Any section? No, that was the other one. Sides. That one. Okay. Okay, just patience. Technology is an ally, but sometimes it doesn't work really.
No.
Okay, no, there is no question, so they have been really clear. So I invite you to do a real big applause. Thank you so much. Now I invite you to come back to the audience sector. And now we will come with the first networking space. I just want to check if, yes, we have the speakers for this session. I'm having the internal check with the team. So the first speaker is the Dr. Levent Arslan from COSGEB is here. He's the director of COSGEB, sorry for the pronunciation. He has an extensive experience supporting SMEs for innovation, sustainability, and entrepreneurship initiatives. He holds degrees in chemical engineering, European environmental policy, and business ethics, and leads programs strengthening SMEs' competitiveness and safer business models. So now we give the word, please.
Thank you.
Also.
Thank you very much for inviting me to this project. Thank you for the introduction. Today I will make a quick presentation about my organization. It's even for Turkish people to pronounce our abbreviation COSGEB. It's very hard, but actually we are a governmental organization, and COSGEB stands for the Small and Medium Enterprises Development Organization of Turkey. it's a public organization, and we give financial and technical support to Turkish SMEs. We have very different support programs such as entrepreneurship, capacity investments, green transition, digital transition, and also we have support programs for global competitiveness. Actually, I would like to just mention about some issues. For example, today we had the opportunity to listen about new technological developments about sustainability and circular economy. For example, if a Turkish company would like to invest in their production facility for a green transition project, we give financial support for that organization. So this is what we do actually right now. We are a very well-developed organization, and we have branches in all of the cities of Turkey. Actually, I would like to mention some of our support programs. The first one is the Turkey Green Industry Project, which is actually financed by the World Bank. It's very nice for me to today meet with Umberto. He's not at the room at the moment, but we just met outside. Actually, that was a project managed and financed by the World Bank, and we had this fund in Turkey and funded Turkish SMEs in their green transition projects. This project was a critical initiative for the Turkish government's efforts to improve and finance the transition to a green economy. Actually, in that project, the project budget was really very high. Actually, this was the most highest budget from World Bank to Turkey. We did a very good job to utilize this funds in the Turkish SMEs. And the project has two poles. The first one is solar energy investments by industrial SMEs. And the second one was more familiar with today's subject. We funded the clean and circular economy projects of Turkish SMEs with the World Bank budget. Actually, I would like to finally mention about our Enterprise Europe Network project. Maybe our colleagues from European countries or other countries are familiar with this Enterprise Europe Network project. It's one of the biggest networks in Europe, and COSGAP is the national coordinator for that project. And I am the manager and sustainability advisor in the Asian region for that project. What we do that we make partnering and matchmaking opportunities for SMEs. This could be in business opportunities or also for the research of opportunities. Again, if I would like to give an example from what we are doing today, if you develop a technology, if our researchers that develop a technology about circular business, and they can have a profile in our network that they can transfer this technology to other companies within the network. So this is what we do. We do matchmaking projects. Also, circular economy, digitalization, resilience, internationalization, access to finance, innovation, and technology transfer are the focus of that European Enterprise Network project. And until now, we put very good job. This is not only for Turkey, but the whole network of these numbers. And finally, regarding the topic for today, I would like to give some examples what we have done in Izmir. Actually, until now, we didn't have any circular economy or sustainability project funded by COSGAP in Izmir in textile industry. But we have one company in Bornova. They produce decorative materials out of recycled plastics, and companies can use this in furniture industry or for decorative purposes for architecture. Actually, we have another company that produces decorative objects out of the residues from mushroom plantation. And also in our region, most probably you have came across that we are good at olive production and olive oil production. We are taking part in this Oasis project where we give companies information about circular business models to utilize their food waste and make it as an upcycled product. Okay, this is, I think, all from my side. Once again, thank you very much for inviting us, and I wish you good luck with that project. Thank you.
Thank you very much, Mr. Leven. It was really interesting. And I think that I would like to have a little chat with you after, because for the knowledge of everyone, I am collaborating in PLASTICE from RINA Consulting, that one of the other, a lot of consortium members that we have inside the project. And I am behind the workshop organization, but also the replication studies, working in collaboration with other stakeholders, for example, as a polymerist. And I think that we can start to have next conversations together with you, also with ecosystems, that is other European platform dedicated to the textiles that will be also participating this afternoon. So keep motivated this attention and applauses, please. So now I would like to give the word to the next speaker. You already know him. He already participated, showcasing one of the technologies today. But now we will speak a little bit of what they are doing in particular and how we can learn a little bit more about the development of materials. So please, Eros. Other applause, please.
This one, right? Yes. Okay. Thank you very much. Okay. Good morning again. Thanks my colleagues to give me this occasion to talk about my company, because I'm in the more comfort zone, because now I speak something that I know quite well, because my background is not in plastic but is in steel making, because I'm an expert in steel making product process and also in integrated steel plant and electrical furnace. So, but we have a look out to the company I work is RINA today. It's a very big company, worldwide company. This is some main figures of this company. It is spread all over the world, but the company has RINA has different branch, and one of these branches is RINA CSM. RINA CSM is a different legal company of RINA, but in the same group, of course. And his history is quite long history, because it was founded in 1963. The origin of the CSM is a metallurgical research center, because in the past it's very focused on the metallurgical aspect. During the 65, 63, the Italian government, there is a big gap between the capability and knowledge of the steel industry in Italy and the rest of the Europe. For this reason, the government decided to realize, to invent this research center. And so for the first 20 years of this history, CSM worked only for the national steel, because in the past, in Italy, in the past, the steel is a national asset. After, during the 18 years, more or less, the steel became private. Also, the CSM became private and started a long period of privatization. So, during the 2013, RINA bought the RINA CSM. So, this is some data, some figures about CSM. So, in the CSM, we are about 250 personnel technicians and the degree. So we have different laboratory, about 11 laboratories, a big pilot plant. As I said before, we focus on the characterization of the steel. We have a chemical laboratory, metallurgical laboratory. We have some pilot plant where we can test the materials and also the process in a small scale, of course. We are very focused on the European project. Historically, we worked probably for when the CSM started, born for research fund called steel. In the past is called now is and working the steel project and also coal project. But now we are working with, of course, the research fund called steel. We work for the Horizon Europe project and so on. We have different, the headquarters is in Rome, in the south part of the city, but we have a different office also in the south part of Italy and also in the north part of Italy. In particular, I have to say that we have an office inside the Tenaris steel plant, and also into the Arvedi steel plant in Umbria, the central part of Italy. So this is the main competences reported here. This material design, performance, and manufacturing process improvement. Now, CSM is performed various spread of activity, but in this presentation I want to focus only in a small part of the activity CSM performed in terms of the valorization of the role of the plastic of byproduct that come from also different sectors. So here reported some project. This is completed in the past we performed. So this is the main topic. This is the valorization of end-of-life vehicles, gasification pyrolysis, and innovative process for circular economy. The CSM is focused on the first point in the valorization of the end-of-life cycle, because in the steel production, the scrap is one of the main elements. Automotive scrap is one of the main elements to produce the steel. And typically, is the steel factory. Some steel factory has a part of the plant when buy the scrap, also the vehicle, have to separate the ferrous part from the other part that typically is plastic, textile, and so on. And for this reason, some of our activities focus on the end-of-life vehicles. Okay, this is the second point, is about gasification and pyrolysis. Also in these cases, we have some plant where we performed some tests. And okay, and the circularity is, I want to say that the circularity, for my point of view, and for steel making people, is not news, because in the steel plant, the circularity is existed for a lot of time. Each byproduct in a steel company, each byproduct is usually as possible into the steel plant. So, of course, there are some waste, but a lot of byproduct has been used. I want to have a look on this project. This is come from a automotive shred residues ASR, and to transform this material, this is come from the vehicle, this assembling, and to transform it into the electricity. This process is being realized, is in part scale, of course, through the pre-treatment of this material, because this material is very heterogeneous and is very complex because containing some part is typical copper, typical aluminum, and so on, as to remove as possible in order to obtain a material as homogeneous as possible, and then gasify it to produce a syngas that can be used to transform in electricity. In this case, it's necessary this pre-treatment to obtain a final product with high quality. This is the last 2 points. And produce electricity. This is a chart flow diagram with the main treatment. The end of life plastic residue is also called fluff. Okay, let's move another interesting project. This is a European project. It's come from a European project. As I personally followed 5-6 years ago. This is focused on the utilization of automotive shred residue, but not for produce electricity, but to produce steel. In the steel process, probably a lot of you know that they use carbon. The idea is of this process is to substitute the carbon with the automotive shred residue, so the fluff, because to contain carbon. In these cases, this material after the production is being added into the electrical furnace in order, because the carbon has a different K role in the electrical furnace, because they provide energy to melt the scrap, and also they support, of course, the production of the steel, because the steel is composed by carbon, and we need carbon for mechanical property and so on. And the third and the last aspect, maybe more important, the carbon is they improve the efficiency of the electrical furnace process, because they favor the production of gas slag that have some kind of protection of the steel during the refining process. And so the idea of this process is to substitute a part of the carbon with this type of material. As of course, it's not possible to put plastic as it is, or fluff, or too much as it is into the electrical furnace, because it's not efficient at all. So the idea is to transform it in briquettes and then to charge it into the electrical furnace. This is the process flow that we applied to obtain this material in these two final fraction. We have the light fraction and heavy fraction. We briquette it and charge it to the electric arc furnace. And I want to show you, yes, another project. This is mainly focused on the process treatment. It's out of the steel process. It's not steel process, of course, but it is related to the also end of life process in order to separate it, the fluff in various fraction that is more easily to use in various processes. Last but not least, I want to show you a very helicopter view of this project. Of course, this is mainly focused on the steel production route. In this case, it is not focused on the plastic, but in all byproduct that is produced into the steel plant. So we have, example, a rolling mill that produces scale and sludge. Also, in this case, it can be reused into the steel route. We have, for example, the second, we have the electrical furnace or electrical furnace, ladle furnace converter. We produce slag that can be used into the steel plant. We have Isarna processes produce dust, and also in this case it can be used because all this material, this dust, this sludge, contain a part of ferrous that can be used to produce steel again. And then we have the sinter plant. Okay, the last one is the sinter plant. Also in this case, it is possible to use the byproduct that come from this plant. So the idea of circularity is not only in the plastic, but also in the steel sector. I think that is my last slide. I complete my presentation. Thank you for your attention. I hope to be clear.
Thank you, Eros. A quick reminder to all the people here and also online, you can start to think about the questions. Please do questions. This is the moment also to have doubts, and all doubts are really appreciated, as well as the questions. Thank you so much, Eros, to also overcoming about the processes, challenges, and experiences you had in other recycling processes. So thank you so much. And now we will receive the next speaker from Total Energies, Marie Chaplain. She's a research engineer at Total Energies, specializing in chemical recycling of polyolefins. Sorry for my pronunciation, polyolefins. She contributes to the operation and optimization of the Grand Puig's chemical recycling plant, working on feedstock diversification and circular polymer development. So please, Marie, a big applause.
Hello, everyone. So my name is Marine Chaplin. So I'm very happy to be presenting today from Total Energies. So as I was introduced, so I'm a research engineer, and I also happen to be work package leader within PLASTICE, responsible for all product validation. So I will quickly, you can go slowly, you will have time. Okay, we have time. All right. So I will I will quickly introduce Total Energies. So I think maybe you are familiar with our company. So we're historically an oil and gas company who have decided in the last 5-6 years to diversify our activities in the renewable energy sector. So to accompany everyone on a energy transition. So we're now diversifying into electricity production, renewable molecules, and biomass gasification also. So Total Energies is present worldwide. So we have both upstream activities for oil and gas applications and downstream activities. So 14 refineries worldwide with 2 biorefineries, so incorporating some circular renewable molecules in our activities, 23 petrochemical plants, and 6.8 million metric tons of plastic sold. So here is a map of our activities. As you can see, we're present on all of across the world. So in both for the refining application as well as some more circular projects. So one of them, namely, is our PLA, so biopolymer plant based in Thailand, in Rayong, on the right-hand side. And we also have some upcoming recycling facility in Grand Puy, so in the Paris area, and I will discuss this more later on. So TotalEnergies' ambition is to invest in some renewable molecules, as I mentioned. This is in accordance with our collective desire to go to a more sustainable future. So one of our target ambition is to be a major player in renewable fuels, so sustainable aviation fuels for decarbonizing the airplane industry, with a target of 1.5 million tons a year of SAF produced by 2030. And in addition to that, we also have a production of circular polymer ambition, which is a strong ambition. This can only be reached together with society, meaning that a willingness for the society to move on to more circular products is necessary for us to achieve this target ambition. And of course, we also have some targets in CO2 and hydrogen molecules. So this is to valorize the CO2 that we may emit and produce in our day-to-day operations, and also try to decarbonize all of our installation by using alternative fuels. So for the R&D sector of our company, most of our activities focus on three main thematics in order to look at circular alternatives for polymer production. So this is aligned with our ambition for the 1 million ton circular polymers for 2030. We have a main axis on the mechanical recycling. So we strongly believe that the shortest loop is better. So if we can valorize as much as we can through mechanical recycling, which has a lower carbon footprint, we try to maximize this. When we cannot recycle mechanically the polymers, then we move to our other solution, which is to do what we call advanced recycling. This is basically chemical recycling, so similar to what my colleague presented for the microwave pyrolysis, but here we use conventional heating techniques. And then a final axis of our research is to incorporate more and more biopolymers in our portfolio. So here I will quickly describe the Grand Puy d'Argenville complex. So Grand Puy historically is a refining complex in the Paris area, and it has now been re-facilitated into a green refinery. So there are three different projects in one site. The main one is the plastic advanced recycling plant that I will tell you more about, and also some biofuel plants in order to produce some sustainable aviation fuel. We also have a biomethane unit and a photovoltaic farm on site. For the plastic advanced recycling plant, the target capacity is about 15,000 tons per year of plastic waste to produce 10.5 tons of oil per year. This oil will be used in our Antwerp refinery and will be used to create some new virgin quality plastics. This is a joint venture with Plastic Energy, so using their technology. And the startup is expected at the end of this year. Hot commissioning is underway. So we're very excited to be able to produce the first drops of in-house pyrolysis oils to incorporate in our activities. So here is the main, let's say, part of my talk. So I put the scheme of the recycling for plastics here, indicating that where we, as TotalEnergies, come into play. So the shortest loop is through the mechanical recycling, and we have lots of activities in this area. Namely for the automotive industry, which is a big client. And then the one I'm here to discuss today is more for the chemical recycling loop using some conventional technology, the one that will be start up in Grand Puy at the end of this year. I think my colleagues already mentioned a couple of the challenges. We can extrapolate the ones that they face in the textile industry to the one we face in the consumer plastic industry. I separated them into three categories. The first one being technical challenges to overcome. The first one would be the feedstock. So feedstock is available, but it's very dispersed. So we need to centralize it somehow and bring it into one location for pyrolysis to occur. It can be challenging and it can lead to additional costs, which is why our current plant is based in a highly populated area where there's lots of volumes that we can gather. The second one is the pyrolysis oil quality. You have lots of things in your plastics. Well, this doesn't magically disappear in a pyrolysis reactor, as some of us know in PLASTICE. you sometimes, most of the time, find it in your oil. And the problem with that is refining in petrochemical facilities are highly optimized facilities, very expensive ones, that don't tolerate very well impurities. So you want to have an oil that has the quality that is sufficient enough for you to be able to put it in your steam cracker for production of circular polymers. This is one of the main challenges. There are, of course, some ways to overcome this. So some companies like Shell use some upgrading technologies. So they clean their oil in order to reduce the poisons that they can find in the oil and facilitate its incorporation. And this actually leads to another technical challenge. How can we maximize the amount of oil, pyrolysis oil, we put in a steam cracker? Right now, we are quite limited technically with the amount of volumes we can put. So the way we do this here is we never put 100% of pyrolysis oil in a steam cracker. It's always done in what we call co-processing. So we put some fossil feedstock with some circular feedstock into the steam cracker to mitigate the quality of the oil. How do we maximize this? This is the main challenge for us. The other type of problems we can have is the volume availability. There's not that much pyrolysis oil available on the market currently. Quite hard to buy it. The second type of problems we can encounter are more economical. Pyrolysis, it's quite an expensive technology, capex-wise. So you need to have a good business case in order to be able to get a good return on investment for your facilities. And it's highly dependent on where you plan to install it. The other issue around here is linked to regulation. I think Umberto mentioned it, the willingness to pay. So the plastic we'll be producing is exactly identical to the fossil one, but it's 3 times more expensive. So how do you manage to sell your product to a customer? Are we willing to pay 3 times as much for the same product just because it's circular? And finally, one main area still is on the regulation. So there are lots of European incentives right now for promoting chemical recycling, and it's why I think it's so dynamic in Europe, but there's still a long way to go. So all of the targets, recycling content targets, are really critical for us to be able to make a profit on the chemical recycling loop. And some of the companies have made vows to incorporate more and more recycled content. So some industries, they have to go through chemical recycling. They can't use mechanical recycled products. So I'm talking about all of the food contact applications, cosmetics, medical. If you want to increase the recycled content in those areas, you have to go through chemical recycling. And without strong incentives, well, it's not as easy to overcome. So yes, so this is the main things I wanted to share with you. Thank you for your attention.
Thanks, Marlene. So now we have online joining us the last speaker for this session. So be ready for the questions that after hearing Michela Mattia, also from Mira Consulting, talking about circular effects, other European projects, the project. Michela is focused on designing, harmonizing extended producer responsibility schemes for textiles. And she has a background in industrial chemistry and supports industry alignment with European sustainability policies. So Michela, please, the floor is all yours. And from here, we are pleased to listen to you.
Thank you everyone, and thank you for inviting me today. Can you see my screen?
Yes, we can see your screen and hear you well.
Okay, thank you. I'm Michela Mattia. I work as a project manager in RINA Consulting. RINA was already presented by my colleagues. In particular, I work on a team, R&D team related to sustainability, decarbonization, and materials. Today, I will present the CirculaTex project, so we go back to textile sector, but differently from other projects that we heard today. In CirculaTex, we don't focus on technology development, but more on supporting the development of policy and the best practice. In particular, in fact, the focus is on development of criteria and guidelines to support the implementation and harmonization of extended producer responsibility schemes.
Here are some generalities of the project. We started in January, so we are in the beginning of the project. It will be 4-year project and has a budget around 6.6 million. It is a European funded project under Horizon program. So our consortium is composed by 19 partners located in different countries, 9 countries. In particular, Rina is the coordinator of the project, but we have different profiles in our consortium. We have, for example, Textile Association, we have a research center on textile, brands, we have a sorter, recycler, also expert on digital labeling system, and also producer responsibility organization. So the idea was to have an overview of the different point of view in the textile value chain. So as I said, the project focuses on the implementation of extended producer responsibility schemes. If you are not familiar with the EPR, EPR is a policy approach that wants to make the producer responsible for the entire life cycle of the products that they make put in the market, so including also the post-consumer stage of these products. In particular, it will be applied to the products some eco fees that want to cover also the waste management cost of the product. This eco fee will be collected, and the idea is that under the EPR framework, they will fund the end of life management of such product. So from the separate collection to the sorting to the preparation for reuse and for recycling, the recycling itself, as well as other activities, for example, industrial symbiosis, textile production. So the idea is that this policy wants to support a change in the textile value chain and make it more circular. How Circulates want to support this implementation? So first of all, we are in this initial phase of the project, really focus on stakeholder engagement and co-creation approach. So we are trying to identify which are the gaps and needs that are still pending for the implementation of EPR, which are the potential solution studies that are already being done in this focus. And what we will do is to study the different national ecosystem, the different maturity of EPR already existing or under development, as well as the different business model of the PRO in the different countries. So what we will do is to develop these criteria that will be applied to real case studies for case studies that we have in our project in order to validate the solution that we will develop. There are also other complementary studies that we will carry out during the project. For example, the study of the textile value chain in order to understand and give a suggestion on needed modification for a circular textile value chain. In particular, also focusing on the study of the different existing technologies, giving also suggestion on the most promising technologies. We have also the development of a digital labeling system that will be developed especially to support the extended life of textile products. So at the end, all the results of the project will result in a recommendation that will cover from the eco design to the reuse and recycling, and of course also the EPR implementation. Most of our deliverables will be public, so also this recommendation will be public. As a last slide, I wanted to show the case studies that we identified. In particular, 3 of them are focused on the brand that we have in our consortium, and the idea is to study EPR applied to different products, but also in different countries to study possible harmonization. The last case studies instead focus on interior textile, especially on carpets. That was very relevant, especially in some countries like Belgium and Netherlands. So yeah, we are now really active in the phase of co-creation. So in case you are interested to know more about the project or be involved, you can contact me or text us on our website. We are really willing to confront with all of you. Thank you.
About your project, and now just is the space for the questions. So I just look in the beautiful faces I have in front of me, also from Turkish people, maybe from some textiles as well. If you want to maybe raise your hand and do the first question, let's break the ice a little bit. Silvia, yes, please.
What kind of
Okay, if the people that is online could hear pretty well, Silvia, or we should repeat the question. Can you make a little bit louder, please? Yes.
Thank you, maybe.
Yeah,
Okay, yes, I asked what kind of mechanism will support small and medium enterprises to adopt circular practices. I don't know if now you can hear me well from.
Okay. I'm doing eye contact with one of the speakers, just waiting if maybe he has something to say.
Sure.
Yes,
Actually,
please.
I don't know if that's directed to me, but my organization.
Yeah, also the speakers that are in questions can join also the part for the questions and answers. So I need for us. Thank you.
Thank you for the question. Actually, while I was listening the presentations, I was just thinking in my mind that mostly we are talking about large enterprises here, like the last presentation was large enterprises. But the transition to circular economy or transition to a green transition should be inclusive for small and medium enterprises. And what my organization is doing, that we are focusing on small and medium enterprises. As I mentioned in my presentation, we have financial support programs to improve this transition because funding is very crucial for the SMEs. For example, companies like Sun Textile or Hugo Boss or some other large companies have efficient resources like human resources or capital or money to fund these projects, but SMEs lack of these sources. So as an organization that gives financial support, we emphasize this for the SMEs. And in addition to these financial supports, we give technical assistance for Turkish SMEs to help their path on their transition to a green economy and circular business. For example, we give like 20 trainings in Izmir in various industries about circular business models. And now we were talking with representatives from Sun Textile that we can develop a project to include the SMEs in their supply chain, or let's say the value chain, to make this transition together, because we cannot exclude the SMEs in this transition. Actually, in addition to that, we are working with startup companies like many of the large enterprises. They have sources, but they are not very eager to do the all research and development by themselves. So they have an ecosystem background, they have startups, they have small companies in their ecosystem to help their sustainability problems to help them. Okay, thank you.
Thank you so much. It was really interesting, this answer. I don't know if all the other speakers have something to add. Tanya,
I have a quick question. Yeah, I have a quick question. It was a nice talk, Michelle. Just a quick question. What do you mean by digital label?
It will be both physical and digital label that will follow a little bit the digital product passport that is developing.
Okay, so there will be traceability then, like that's what you want to trace the product.
Yeah, it will be praised also on the product. Yes, there will be also a physical part.
Okay, thank you.
You're welcome.
Okay, thank you, Tanya, for this question, and also Michaela for answering. I think that then for the next vlog after the break, the lunch, it will be interesting to check a little bit the microphone with you, Tanya, because I think that we from here cannot hear you pretty clear, and the people online seems that they can hear you pretty well. So we will be checking this technically. I will reach you.
Okay, please do. Yeah.
Thank you. I want to see if there is any other questions here. Perfect. Yes. 3 hands. Whoa. The first one, please.
I'd like to know textile industry. My question is about the textile industry and clothes. Do you consider eco-design, for example, for the clothes and the textile itself, the yarning, material that can be easily recycled? Those who are I'm sure that some clothes are very difficult to recycle because of the design, because of the model. So the model, is it considered also, or? Thank you.
Thank you. Who wants to address this question? I don't know from which side. Also, if other of the previous speakers here present, also online connected, wants to add, they are more than welcome to do so.
Maybe I can tell something. Yes, also I don't know if can you hear me well because I have some noise.
Yes, Michaela. Yes,
okay, sorry. Yeah, also in our project we are considering, of course, eco design and of course the materials that is used is one of the focus for eco design.
Perfect. Also, Marine wanted to say something. So please, Marine.
I think maybe I didn't mention it in my talk, but for all the plastics packaging also, there's a big work done on the reduction of volume. So reducing the mass of each packaging, the complexity of the packaging, reducing the number of layers and the number of materials. It's also something that's really being investigated at the R&D level in our company, and is, I think, a pathway for the future. We can't continue producing such complex materials that we can see here within plastics, how complicated it is to sort it, treat it, and valorize it.
Really interesting.
I would like to also make it just not an answer, but a contribution. We know that about 70% of the environmental performance of a product is set during the design phase. So it's really very important to design, even if it's a cosmetic product, even if it's a machine or a textile product. The most crucial point about environmental performance is the design phase. So it's a very good point that we raised there.
Totally agree, and thank you so much. If no one else has something to add for this question, thank you for the question again. There were 2 other hands up. Please stand up.
My question was about the social acceptance of the new technology. Which are the main aspects controlling the social acceptance of the technology? Thank you. For example, I know that during the pyrolysis, the oil is not like a part of the stove.
That is a very good point, and we actually have this issue at the research lab already, where our colleagues are not always happy to receive pyrolysis AS samples in the lab. So that it's a problem. So the social acceptance, I think, needs education. So the education is needed to try and promote the chemical recycling pathway, because it's not really understood by, I think, the general public what it means. It's often seen as either greenwashing or not a real solution. And I think it's a shame, because the waste we have currently exists. I mean, I think Suke mentioned it's 350 millions per year. It's there. So we need to valorize it somehow. The technology, the solution we have at hand right now is through chemical recycling. So social acceptance is a huge issue, and I think a lot of communication is needed by all stakeholders in order to promote it and explain it to the general public.
If I can add something connecting the first question with the other one, I think that also the awareness through education for this social acceptance, it's a key issue and a key, let's say, tackling or let's say enabling factor. Also considering in a specific note, traceability. You need information about alongside all the value chain. And also the SMEs can play a real critical role to be included, but also to enhance big companies, bigger industries that have a lot of fragmentation and regional fragmentation of the value chain of production to really be at the same level of compliance that, for example, the European Union is required for the next year. So I think that we are slowly, but I like this kind of interaction. We are finding a little bit the key messages for today. Eros, you wanted to say something?
Yes, I want to say about is a very important also for steel making industry, because steel making industry is a very pollutant company, industry sector. And it's very important, of course, for the company to give a big transparency on what they done inside, organizing open days in order to understand the people that are living around what happened inside. Of course, it's necessary to guarantee a good quality of air, good quality of water, avoid the emission that can be seen, and try to do up to date the equipment and also the control system that can also to remove, to minimize the emission. But however, it's a big issue. So, no, I think not only for steel making, but also for the big industry or alphabet industry, also petrochemical and so on.
In your contribution. Thank you so much. I don't know, I think we have one last question in presence. Yes, please,
Several.
Okay.
But maybe they have like short answer. The first one will go in order to Veros, because we've been talking about recycling rates, but in your case, I think it's also an industrial symbiosis rate between the automotive sector and the steel making sector. So this is a quite technical question, but I can just present myself. You were mentioning about direct valorization of the fluff being introduced in the furnace, but as you are also implementing gasification, have you also tested the use of the char produced in the gasification stage to be also fed in the unit, or
yes,
to compare with the fluff, or
okay? So if you mean the char that comes from the fluff,
yes,
or the char in general?
I mean, I understood that you also gasify the fluff.
Yes,
to produce gas that is further
yes,
to
okay.
so on. But if you have tested just to check the difference between just the raw fluff, let's say, in the EAF or the char coming from the fluff.
Okay, the problem is the char coming from the fluff is very low, because the char fluff is plastic material, so the major part is a volatile material, and the char is very the fixed carbon that is obtained. The char is a few percent. So, but for sure, the electrical furnace, I don't think it is so fluffy, but there are some activity that use biochar mainly, that come from biomass. This is more efficient. Of course, is higher cost, more efficient because the quantity, the percentage of volatile matter is lower, so the efficiency which the car carburized the steel is higher. So you stuff a major part come out like gas that come very over the burn during the extraction.
The other questions? Yeah. You asked for questions, so I have questions. Yeah, the next one is for Marie, because you mentioned about the increase of the oil. So it's something I know it's quite tricky for you. Now you are co-processing, but in the future you might not be able to co-process such a big amount of let's say, conventional oil coming from alternative sources. How are you dealing with this issue? Are you, in terms of R&D, are you expecting on, I don't know, working that issue from the very beginning of the value chain with the raw plastic, or are you expecting any post-treatment of the oil to reduce that?
That's a really good question. It's a question we have at R&D level. Where do we treat the impurity? From the feedstock, because that's a possibility. You can try and upgrade your inputs. So you can say, I'm going to clean my waste, remove as much as I can that can cause problems downstream. Or do I upgrade my oil? So do I just take any feedstock and then, depending on the product, then I work on the product and how to purify it? It's economics. So it's all about what makes the most sense economically and also technically. So we look at the entire value chain. So we look at technologies for purifying the waste, different ones: washing, hot washing, cold washing, friction washing. From a LC also standpoint, because the more steps you add, the more cost it adds, and also the more impact you have on the environment. And for the downstream part, we also look at several possibilities. Some washing of the oil, some adsorbents maybe could be an opportunity. Some fractionation could be an opportunity. So yeah, lots of strategies available. No clear pathway, I would say. Some competitors have taken a solution. They've chosen to go to work on either the oil upgrading. So I know Shell, for instance, has one of their oil upgrader based in the Netherlands, but it's not so clear where the value lies. So it's still very much an open research question for us at TotalEnergies. No straight answer to give at the time.
I understand each company has
it's a strategy.
So what I understand is that the petrochemical processes try not to be too much modified. So you have to work
down upstream.
And it's good you mentioned the LCA point, because my next question was to Micaela, because you in the, I don't know, Micaela, can you hear me well, or you mentioned, okay.
Yeah, more or less.
So I have to go with that. You mentioned you've been, your breaks really focus on the EPR, but I was wondering, as your other colleague mentioned before about SSBD standards and so on, in your break, are you also expecting to somehow link that two frameworks? Because I'm not an expert in this, but as far as I understand, it's like two different frameworks that are pretty closely related, because one comes to the beginning of the value chain, let's say, the materials you're using, and the other one is at the end of the value chain of the material. So how could that be interlinked in terms that you don't somehow lose traceability of information, that everything somehow could be complementary, but not, like duplicating efforts or duplicating the info that could be related to the final or end use of this product.
Yes, okay. Also in our study, we are trying to consider all the, let's say, sustainability aspects that are considered also in SSPD. We will consider, for example, environmental, economic and social aspect as well, while analyzing also our recommendation. Maybe a little bit less on the safety part, but just because we are not developing new technologies, new materials, so maybe that part will be more on the state of the art analysis. But as I said, we are not focusing just on EPR. We wanted also to give some complementary solution, complementary guidelines, and one of these is on eco-design. So we will have a big part that is focused on eco-design as a complementary, let's say, recommendation to the EPR itself. So, since, as we know, EPR is a good instrument, but it wants a little bit to, let's say, cover the failure of the market, the fact that some more sustainable products are not economically sustainable. So EPR want to cover a little bit this, but we hope that in the future it will be maybe not necessary anymore, no? So we are trying also to give this complementary solution.
Sorry, I mute because if not, the people that is connected online cannot hear pretty well with the echo. So can I just say thanks to your answer, Michela?
Thank you.
Thank you again. And also, I don't know if you have something else to add for this question or nothing, but thank you, Clara, also for making these questions. You were one of the people that really listened to me when I asked to make questions. I'm happy for that. But I know that after eating we will be more chill. So I want to say thank you because the first half of the workshop is already arriving to the end, and now it's the real interesting part. Now I'm kidding, but yes, we are going to eat now. So our colleagues from Textiles will guide us to the place where we will find the lunch. The social lunch will begin. So also the people that is online, we are coming back on time for the next vlog at local time, that is 2:30 p.m. At Turkey time. And then this is everything. I just want to ask you a last thing. So a big applause for our speakers online and in presence. It was really interesting. Okay, thank you so much. And now we can start to move on. Thank you. Okay, thank you. We are coming back. So this is the second part of the workshop of today. And now we will have three other speakers from the European community, from Ecosystem. We will have Tila Cross. I will introduce her later. We also have from Portugal, a sister project working on recycling. That is Carla Silvia from TextMeter. It's also part of Ecosystem. And then we also have Tanya Day from India. So today is also international, and this is obviously because we had the chance to do this event in every fall. So before starting, just a quick remember, after this interesting networking session, that is the last of today, we will have the enabling session. So for that session, I will invite you all in presence, online, to share your thoughts, your comments, your insights, your questions, your reflections inclusively. And before doing that, say your name and from where are you from, in which organization are you working on, and the department in particular. So this could be interesting and will help to enhance the conversation and generate the document we will like to propose the signature afterwards this workshop. So without any other prelude, I would like to give the word to the first highlighted speaker. That is a pleasure for all the Textiles Consortium to have you today, Tila. Tila is a sustainability specialist at Ecosystem, working on circular textile innovation pathway and stakeholder engagement. She contributes to transition initiatives integrating research, industry collaboration, and sustainability policy. She will tell you better than me what ecosystem is doing currently and for what they are hoping to do so in Europe. So, Gila, please open your microphone and share your screen. And here we are all expecting to hear you.
Okay. Hello, good afternoon from Brussels. I'm very happy to be with you here online, and I hope my screen sharing is working. I just put it full screen. Does everything look fine?
Yes, we can see.
Yes, everything is perfect now. Okay.
Perfect.
Floor
Okay,
is yours.
Great. Thank you so much. As you already mentioned, my name is Tilla Cross and I work as Sustainability Programs Officer at an organization called Textile ETP. And I'm here to tell you a bit more about one of our initiatives called the Ecosystems Community that PLASTICE is also a member of, and how we try to accelerate collaboration for textile circularity through this Ecosystems community. But to start with, in case you're unfamiliar with what we at Textile ETP do, I thought I'll share a few words about that. So we are the largest community of textile research and innovation professionals in Europe. And our objective is to ensure long-term competitiveness of the European textile and clothing industry through collaborative and market-oriented research and innovation. We're a Brussels-based NGO and bring together many different companies, organizations, clusters, universities that all work on, textile research and innovation. And how do we do this, or how do we want to achieve our objective? So our services can be grouped in 3 pillars. So we engage in different networking activities like organizing an annual conference, several online webinar formats. Then we're also very active when it comes to providing different learning activities. So we have thematic innovation hubs for learning and expert collaboration, where we then invite experts from all across Europe to talk on different hot topics linked to either smart and high performance textiles, circular and bio-based textiles, or digitalization. And part of this learning pillar is also facilitating this Ecosystems community that I'll say a few more words about in a minute. And lastly, one of our core activities is also to support our members accessing EU funding by providing a brokerage system. So, our members can find each other to then apply to these EU funding calls. And we are also the lead organization in this public-private partnership Textiles of the Future under Horizon Europe. So that's just to give you a bit of context of all the different things and services that we at Textile ETP do. And now I would like to explain a bit more what Ecosystems specifically does and what it is. So Ecosystems is the European Community of Practice for Sustainable Textile Ecosystem. And essentially it's a cluster where we bring together different EU-funded research and innovation projects that all work on something related to textile sustainability and circularity. So we launched this Ecosystems community now nearly 3 years ago. And the core idea behind it really was to create a permanent expert community and a central knowledge hub for practical application of EU-funded science, technology, and skills development for textile sustainability and innovation. So basically what we did, I think we started with around 8 different EU-funded projects and then grew really significantly over the past nearly 3 years to now 76 member projects. So we're very happy about that. And I think it also really shows that there is a need to provide this platform for all these different projects where they can meet and exchange because, as you know, since you work on the PLASTICE project and maybe also on others, you already collaborate a lot within one project across different countries. But of course, across the different years and core topics, there are, of course, similar topics that you're working on. So it's not only valuable to exchange within one project, but also to exchange with other projects and share best practices, share knowledge. And this is essentially what we do, or what we try to provide to all the different projects through EcoSysTex. So that's one of the activity areas, inter-project collaboration. And how do we do this? Well, we have 8 different working groups that I'll show you on the next slide. And we also organize joint dissemination activities where projects can well either listen to each other's presentations and be inspired and like do follow-up based on that, or they come together for a joint event. So we also organize a bi-monthly webinar series that we call EcoSysTex Insight Series, where then different projects give short presentations of what they're currently working on and what their results are. And we also organize an annual EcoSysTex conference, where then a few of our member projects co-organize it with us and come up with interactive workshops, and also use it as a platform to collect input or validate the results with the public outside, basically. And another activity area of EcoSysTex is also to occasionally engage with EU policymakers, because of course, well, as it says here also, we have over 440 registered experts from these different member projects in the EcoSysTex community. So there's a lot of knowledge, a lot of scientific expertise. So occasionally we might also consult these experts for their knowledge, for their insights, and then provide it to EU policymakers to inform their policy and decision making. So that's in a nutshell what EcoSysTex is and what we're doing. And now I'll just go into a bit more detail. So here on this slide, you can see all our different 76 member projects. And since, well, the PLASTICE project is working on textile recycling, amongst others, I thought I'd just highlight that based on the data we gathered from the projects, actually approximately half of all our member projects somehow work on textile recycling. So I think there's a lot of knowledge and expertise and potential to exchange on different topics with different member projects, because textile recycling has been a big part of many of our member projects so far. Here you can see our different working groups that I mentioned at the beginning. So all these different working groups are led by voluntary experts from within the EcoSysTex community, and they can sign up to as many as they want. So we have 3 horizontal ones, one on research and innovation gaps and needs, and they published also a paper now, I think, nearly 3 years ago about, well, what research and innovation gaps and needs for textile sustainability and circularity they see. And this year we also launched a horizontal group focusing on skills and education, since we also integrated some skills and education related projects into the EcoSysTex community this year, because we also believe that, of course, there's a lot of overlap and synergies to be created between these different projects as well. And then we have 5 technical working groups, and there are, I won't read them all out, but that's basically the main channel for creating this cross-project collaboration. And yeah, there's one maybe that's most interesting for you, because you work on textile recycling, you're interested in that. So we have the technical group 2 on assessment of different recycling technologies and end-of-life options. And well, they didn't publish any paper or anything like that yet, but on our EcoSysTex website, if you're interested, you can find back a presentation they did on the work that they've been doing, which was linked to providing an overview of available recycling technologies. So that was really interesting. I'm happy also to share the link with you in the chat after my presentation. So yeah, I already mentioned a few words about the different available resources throughout the minutes I've been talking, but we really have a great website, ecosystems.eu, where we bring together all the resources from all the different projects. So we also group them sort of in different topics. So if you're specifically interested in the circular economy and textile recycling projects, you can filter for that. We have a playlist for these projects on YouTube with videos if this is something you're interested in. And also we have on our website an extensive database of member project publications. So if you can just have a look there and find the relevant ones for you, you can also do that. Of course, you're also very welcome to subscribe to the mailing list. We occasionally inform everyone that is signed up there about upcoming events and news from the projects. And yeah, I mentioned our Insight series, these webinars, where there was also a specific session linked to the work that has been going on in the technical working group too. So that and also many other presentations can be, and recordings can be found there. And if you happen to work in a project that is not yet an EcoSystex member, but you think it would fit the scope, of course, you can also always submit a membership request. All of that is available on the EcoSystex website, so do have a look there. Identify the interesting projects that you want to follow and their work that is publicly available. And to close off with my little presentation about EcoSystex and what we're doing, I thought I highlight just some more or less randomly selected projects, but what they have in common is that they all work on textile recycling, just to give you a bit of an idea of what other projects you can find within EcoSystex and when you follow the EcoSystex activities. So there are these 3 ones that I wanted to point out. Maybe you've already heard about them. There's the New Cotton Project that created a circular model for commercial garment production by regenerating textile waste into new man-made cellulosic fiber that looks and feels like cotton, working with chemical recycling. Then last year there was also a project that finished called Skirt, where they demonstrated a complex textile-to-textile recycling system for discarded clothing involving natural and synthetic fibers, as well as fiber blends, focusing on mechanical recycling. And lastly, there's also the T-Rex project that has already ended, and they created a harmonized EU blueprint and business opportunities for closed-loop sorting and recycling of household textile waste, and focused in their work on post-consumer textile waste, and aiming to transform end-of-use textiles into desired feedstock for new business models. And of course, all these projects also did much more than just that, which is already a lot. But yes, I mentioned this is just to give you an idea of what you can find. And lastly, I wanted to highlight also a few ongoing projects that might be interesting for you to follow. So there's the PESCO Up project that develops sustainable and economically viable processes for upcycling mixed polyester cotton textile waste, and works on improving transparency across the recycling value chain. And they focus on the separation and recovery of blended fibers, and also use digital tools for material classification and traceability. Secondly, there is a project called Solstice that is currently implementing a 5R framework in 4 different regions in Europe, namely Berlin, Catalonia, Prato, and Grenoble. So yeah, if you're interested in following Circular Cities and Regions initiative, this is an interesting project for you to check out. And within that project, they also look at chemical recycling technologies, sorting and feedstock traceability, and integrating that then into regional circular textile systems. And lastly, there's a project called CISOTAC, which pilots digital repair and dismantling and also novel recycling processes and also looks at changing sectorial and customer behavior while focusing on 3 different textile areas, so fashion, workwear, and active goods. And then, of course, another project within EcoSys, because of course I can't list them all. There's much more than that. There's the Text Matter project that will also present in this session, so you'll learn more about that from Kat. So with that being said, I wanted to point out some upcoming activities and events that might be interesting for you to have a look at. You can, of course, find them all on the EcoSys website. There's a news and event section. Yes, so there is ZeroF project that is coming to an end, and they've been working on a PFAS-free future, safe and sustainable alternatives for packaging and textiles. And you can also join this event online on the 20th of November. And then from the SISUTAC project that I just mentioned, they have something they call the SISUTAC Sustainability Forum, and organized 2 more online webinars this year, focusing on, well, for one, EU policy developments impacting textile circularity in the end of November, and then one on circular business models in textiles in early December. So with that, I'm coming to the end of my little presentation. I hope this gave you a good overview of, well, what EcoSys is, what we do. If you have any questions about how we organize our work, things like that, you can, of course, contact us anytime. And yeah, thanks for your attention.
Thank you so much, Tila. It was really interesting, and I think that also we can gather some conversations also with Leven Upland from COSRED, the Small and Medium Enterprises Development and Support here in Turkey, that I think that we have common slides to work on, and many PLASTICE can also enable this space and be participating on these new opportunities and table. So without any other prelude, we will have an open space at the end of this slot for questions you want to do, even for Tila, but also for the other 2 speakers. So prepare your questions, start to think about it, even if you have a comment. But before opening that questions and answers, we have other 2 amazing expositions that we will go now to listen from India to the Dr. Tanya Day. She is the R&D manager at SITA, the South India Textile Research Association, and she has more than 20 years of international experience in advanced textile, eco-friendly processes, and sustainable materials and circular innovation. So please, Tanya, now can you please activate your microphone and share your screen? And from this side, we are listening to you.
Thank you, Rupi, for the introduction. So, as you know, hi everybody, I'm Dr. Tanya Day, and I just recently joined in a textile research institute over here. I have spent my entire work life in America and Europe, and I'm currently very much involved with textile material development with a strong focus on environment and sustainability. So let me share my screen. Can you see my presentation in full screen form? Can you see it?
It's yeah, we can see your screen, but not in full screen.
Oh, I have put it in full screen. Now?
No,
Can you do it again? Full screen? Yeah? Not in full screen?
No, it's not in full screen, Tanya.
I have pressed F5 and set full screen in my laptop, but I don't know.
Maybe try to stop the sharing and reshare again.
Okay. Stop sharing and then share again. Sorry about that, just a minute. Okay, share the screen. Screen. Oh wait, maybe it's this one now to see. Is it in full screen now?
I think there's some delay, so we should wait.
Yeah,
I think.
some delay. Yeah. Full screen?
No, it's a black screen now.
Sorry about that. I don't know what's going on. Full screen.
Maybe try.
Not yet?
Try to turn off your camera and share the screen. The important is that we can hear you, not perfectly, but we can understand you.
Make the camera off. Camera
Yes.
off. Okay. Did that.
Exactly.
And
Share
now
the
show the. Okay.
Exactly.
Doing
Exactly.
it. Doing it. Enter screen. Allow. Oh my God! Wait.
Okay. If not, we can share the screen for you, Tanya, if you prefer.
Just one minute, one more try, and then sorry, just one more try, and then I'll let you do that. Just one more try. So I have made the camera off now. Screen, and select the screen is this one, and say allow, and it's there now. And you see the small version, and now F5. Can you see it full screen?
Yes, perfect. It's perfect now.
Okay. Okay, good.
Okay.
Yeah,
The
so
floor is
sorry
yours.
about that technical, yeah, thank you. Thank you. Sorry about that technical problem. So my talk today, textile plastic recycling, and I just have 3 slides, challenges, solutions, and gaps. So I have tried to jot down some of the challenges in this particular area of textile plastic recycling. First is fiber separation, because all of the textiles come in a blended form. For example, it's a cotton polyester or cotton lycra or wool silk. They come in blended form. It's very difficult to separate these fibers because they have different kinds of properties, different kinds of performance. So it's very difficult to separate them. And even though by some mechanical methods we can separate it, there are short fibers there which are generated which have no recycling use. I mean, they don't have any good properties later on. So those are discarded. So this is one of the problem in fiber separation. And as far as sorting process is concerned, which is another challenge, mostly it's manual. All over the world I have seen it's mostly manual, and that needs to be improved. And together with that, when the dye and the heavy metal contaminates it from the textile, it makes the situation even more complicated. And then there is lack of infrastructure, so that needs to be improved. So the sorting process needs to be quite improved. And then there is a huge challenge from this plastic pollution. And some of the main culprits are here microplastic. We have heard about it, very tiny little plastic microbeads, which are 5 millimeter or less in diameter. And they can come from 2 sources. There's a primary source, which is the microcapsules that we use in textile finishing. For example, here you can see a microcapsule where there is a polymer shell, and anything can go inside, any active ingredient, and that determines the property or functionality of the bead. For example, it can be a PCM thermoregulator material, it can be deodorant, fragrance, vitamin E, it can be antimicrobial substance, drugs, or insect repellent, anything. So the idea is that it diffuses through this polymer shell, or sometimes the polymer shell ruptures, and it just delivers it in a targeted manner. But these are very much responsible for this microplastic pollution, and they're the primary source. They pollute the environment because they come out from the textile material and they're going into the water, and the fishes eat it, and the entire ecosystem is disrupted. Another is the secondary source of microplastic, which is when the fabric itself degrades, like polyester, polyamide, polyurethane. These are very prone to degradation. And another thing that we have hearing very much, and the European Union has become very strict in this matter is this PFAS, per and polyfluoroalkyl substance. These are used for hydrophobic and oleophobic coating in textiles, but they are dangerous materials because they are also called forever chemicals. Because if they go into the nature, they never go away from it, and that's because there are lots of CF bonds, as you can see, carbon-fluorine bond, and these are considered as the strongest bond in organic chemistry. So that's why it can never be taken off from the environment if it goes there. And the regulations are very stricter these days for this PFAS. And another source can be this fabric filling, which we oftentimes see in wool and synthetic materials. You can see a picture over here. And then another challenge, I think, is economic viability, the cost of recycling, how can we regulate that, and the quality issues. After recycling, will it perform well? So these are the things that needs to be taken into account as well as challenges is concerned. So what are the solutions? What can we do? As far as fiber separation is concerned, I can say that the blended fabric will stay. We cannot get rid of it. It has huge amount of, good performance, and we rely on that, so we have to have it. This will not go away. But as far as a short fiber is concerned, we can use lubrication, because we can optimize the carding process, and that way we can get rid of the short fibers. And as far as sorting process is concerned, this NIR-based, NIR is near infrared, NIR-based fabric sorter is coming into the market nowadays. You can see this handheld machine over here and a desktop machine over here. This is an excellent tool, and it can not only identify the polymer type, but also gives you blend composition. And if you integrate it together with hyperspectral imaging, then it can be automated. So that is the way to go. This is the way forward. We need that in sorting process. We cannot rely on manual sorting anymore. And incentives and government initiatives are also important to improve the sorting process further. What can we do with this plastic pollution? Well, as far as microplastic is concerned, just go for biodegradable plastic, which is made from waste biomass. So this is over here, you can see this is when I was in Europe just last year. I got a European grant, and I engaged some of my first-year students in this project, and they were super excited to see these beads pop up. You can see these microbeads. These microbeads are not made of bad plastic. They are made of alginate polymer, which is derived from brown algae. So they are sustainable. They are supporting circular economy, and they are good stuff. So you can put anything active ingredient inside. In this case, it was tea tree oil, a therapeutic agent inside. So this kind of microbead, this will never pollute the environment, and this will never cause any kind of hazards and any kind of regulatory problem. So this is the way to go, and I would encourage industries to come forward and take these technologies from us and develop products. Another is that we use binders to to integrate the microcapsules in the textile. So this so that it withstands the wash durability. These binders need to be eco-friendly and organic. That's another thing. And we can also enhance the fiber strength. So these are the ways by which we can get rid of microplastic pollution. As far as PFAS is concerned, development of suitable filter which can specifically catch these PFAS, that is one thing to do, but just to stop the pollution in the first place, we should focus on fluorine-free hydrophobic coating. And in fact, I have a Spanish industry partner with whom I have recently written a grant application, and we are hopefully going to start this project soon enough. And that's where we have taken into account how we can develop a PFAS-free hydrophobic, omniphobic, actually, hydrophobic and oleophobic coating for textile finishing. And we have also taken into consideration the LCA and the design by sustainability, which we were hearing this morning. All these things are there in the project. And as far as fabric filling is concerned, the common methods are take long fiber, yarn twist, singeing, calendaring. These are some of the common methods to avoid fabric filling, and some modern methods are plasma technology, enzyme biopolishing. Economic viability, as far as economic viability is concerned, just go for automation, like I said, NIR-based fabric sorter and automated with hyperspectral imaging. Go for waste valorization, like I said, these microbeads, alginate microbeads, waste valorization. So it all comes down to R&D work. R&D work needs to be improved and strengthened much more. And then the gaps. What are the gaps? We have talked about challenges and solutions. What are the gaps? The main gaps, I think, are joining the dots between innovation, infrastructure, awareness, and economy. If we look at these segments, each of these segments, innovation has some gaps, translational gap, outdated methods. We are sometimes using outdated methods, funding constraints. These are innovation gaps. As far as infrastructure is concerned, inadequate collection and sorting, lack of advanced technology, lack of clear policy and guidelines, limited consumer participation. These are some of the gaps. As far as awareness is concerned, we need to have a clear target group. We need to do a lot more advocacy so that people learn these things. They are not aware at this moment what's going on around us in the nature with these textile products, and local bodies needs to get involved. And as far as economy is concerned, implementation gap is there, lack of circular economy is there, which we have to improve further. And then it all comes down to collaboration. To achieve all these, different types of stakeholders have to work hand in hand, and it all comes down to collaboration. So pretty much that's it. My presentation is quite quick, I know. And I'm open to questions.
Thank you for that. These participants in person are really kind, and I hope that the virtual ones will be also the same if they made some questions. Let's see. I'm just kidding. It would be nice to be charged better. So thank you, Tanya. It was really interesting. It's true. Also, you have been quick, but in any case, if you want to go deep in terms of what they are doing in India, what CITA is doing, we have the open space for questions and answers. After the last speaker that I am glad to introduce you, it's the Dr. Carla Joana Silvia from CTV. She is the Director of Chemistry and Biotechnology at CTV with 11 patents and over 80 publications. She works on advanced fibers, polymers, biomaterials, and circular processes supporting high-performance sustainable textiles. So she's also representing a sister project today, and she's really good and quick also. She's now sharing the screen. So please, the floor is all yours. Carla, we are listening to you.
Thank you, Rocio, for the nice introduction, and good afternoon to you all that are listening to us. And it is a pleasure to be here today to talk a little bit. So we have just some brief overview of TextMatter project, and as well the work that we are performing both at CITEV and in TextMatter in particular on innovative approaches for textile recycling. So just for starting, some brief words about CITEV. So we are the Portuguese Technological Research Institute, a private research institute for the textile and clothing industries. And we have three main core activities. We have the characterization and certification of product and processes. So we are the only entity in Portugal that can do OECO-TEX certification. And we have the full range of all the available certifications and standards for products and processes. We also have a high-level academia for training and coaching, in particular dedicated to the textile sector. Probably you know and you are aware, but in Portugal, in the north of Portugal, we have the full value chain in a very close range. So we have this mission to support also this ecosystem of industry that we have in Portugal. And finally, we have research activities where we do research, in particular in the most demanded areas that we are facing now. So circularity, bio-based economy, circular economy, but also manufacture digitalization, industry 4.0, and so on. One thing that is distinguished for CITEV is that we are quite market oriented. So we do research and applied research. And as we used to say, textiles are everywhere. So we do research for fashion, of course, but also for the mobility and automotive interior, for architecture and construction, for defense, for workwear, and also PPEs, and also for health, among others. And now moving to TextMatters. TextMatter, as Tilla mentioned, is one of the projects that belongs to this ecosystem community of practice. By the way, I highlight what Tilla already mentioned, though. So Ecosystex is a wonderful initiative from ETP. So in this community of practices, they join all the, I would say, all the projects that deal with textile, in particular circular economy and textile recycling. And it is an excellent initiative to demonstrate what you are doing and what are the approaches, the most innovative approaches. So if it's very important if or interesting for you if you are also dealing with these materials. So regarding TextMatter concept, I will not go into a lot of detail. I will just briefly introduce what is this European Horizon Europe funded project into main approaches. So the main core idea is to develop new cellulosic fibers and yarns from both from residues, but I will go into there, and also biofinishing and bioformulations for textile finishing. So as the raw materials, as you can see there in the first biggest circle, we are using agricultural residues that are a very interesting source of several bioactive ingredients, but also algae. So we are using both micro and macro algae to extract alginate, for instance, as you saw in the previous presentation. It's one of the ingredients that we can extract from these sources, but also post-consumer cellulosic textiles, textile waste for retrieving both the cellulose fraction for what you see there in the green circle, to develop new fibers that and yarns that can be performed by wet spinning, but also conventional cotton spinning, and also for develop new formulations that we can apply for dyeing, for finishing, and for conventional dyeing or coating or printing processes, in order to develop our demonstrator that in this project are mostly focused on home textiles and fashion. And one thing that is important in this project, that in all the R&D tasks and all the approaches, we are using a safe and sustainable by design, and that is something that we will evaluate always, the toxicity and the alternative end-of-life options. And also very important focus on consumer, and that's why we have a work package that is dedicated only to consumer research to promote these approaches. So regarding the textile recycling, and you can see there an image of the campaign that we launched this year to collect used textiles, so post-consumer waste textiles. The majority of this fraction would be for recycling, and I will show the approaches that we will be exploring in this project. But we also meant to stimulate other end-of-life options. So not only recycle, but we should foster the remake, so small garments that just need some buttons, or so something that can be remade in order to be reused. And some of these post-consumer waste, they are in good conditions to be reused immediately. What you see there in this schematic diagram is an image of our sorting line. As you also saw in the previous presentation, we also have a near technology embedded in this system, but also hyperspectral cameras, and we are mixing as well with artificial intelligence in order to have a separation. It is a pilot line that we are installing there at our facilities at CITEV, but it will enable to have this separation by color, composition, but also fabric type and other requisites that will make the recycling much more efficient. As you know, if you have the separation by these characteristics. And then you also see a vision of our mechanical recycling line and also our reactors, but I will go into a small detail there. Just mentioning that we are focusing on making the change for a truly circular value chain. And to do this, we need to have, for one side, materials that can be reintroduced back into the textile value chain, and also promoting zero waste processes. So in all the stages of the value chain, right from the spinning, but also to making, weaving or knitting, making this textile structure, dyeing and finishing, confection, and so on, we are always promoting processes or trying to improve the efficiency of processes in order to generate the less waste as possible. And all the waste that is generated, we are introducing back into the textile value chain. For that, we are using eco-design approaches, of course, but also eco-engineering tools. And when we reach the end of life, we are promoting innovative recycling approaches, of course, mechanical, that is well implemented, but also chemical and biotechnological enzyme recycling approaches. And the goal is to have always upcycling initiatives and to generate also new business models so we can keep this industry as a circular industry and promoting the circular value chain. As for the approaches and considering textile recycling, we are using our mechanical recycling line that you see there. Our line has capacity to process up to 100 kilograms of textile waste per hour. As you see there, the first approach is always to remove all the hard parts and accessories, and then we do a first cut, and then we do the fibrillation in order to individualize the fibers that we can now use them also to retrieve new yarns, or depending on the quality, and if we are having lower quality fibers, we can produce non-woven structures, as you can see there. But we are also, and in particular in Text Matter project, because it's, as I mentioned in the beginning, we are using cellulosic textile fractions, so cellulosic residues. So we are stimulating and promoting also the chemical and the enzymatic recycling. And for this, as you can see there, we have one first pretreatment step where the goal is to remove the color and the dyes and all the finishings that we have on the post-consumer waste. And this has several goals. One, of course, is to increase the added value of the waste, because as you know, and as maybe I didn't mention, but as you see here, when we do mechanical recycling, and if we are not sorting by color, what you get at the end is always this greenish yarn and structure because of the mixture of all the fibers and all the colors. So when we remove the color, by one side, we increase the added value of our material. But more important than that is that if we want to move forward. Yes?
Carla, to interrupt you.
Yeah, I'm taking more time, right? Sorry?
Yes, if you can repeat the last things you mentioned, because you have a problem of connection. Sorry.
Okay.
No, it's not for the time. Don't worry for that.
Okay.
It's because you have a problem of connection, and some words you mentioned just a while ago we couldn't understand. If you can repeat a little bit, please.
Okay, sorry. I hope you can hear me now. So as I'm mentioning, the color removal, I think I was in this part. I was mentioning that when we do mechanical recycling and if we don't sort by colors and if we mix all the waste, we get always this greenish typical recycled fiber. We are all aware of that. So when we are promoting a chemical recycling, we are trying also to remove this color and finishing agents. And this has several goals. One is to increase the added value, of course, of our waste, because if we remove the color, we can do this on fabric level, but also on fiber level. But for instance, if we are removing on waste that is a fabric for industrial waste, for instance, you can re-dye and you don't need to consider that as waste because you can move forward in the process. On post-consumer waste, we remove the color, so that means that then we have a full range of possibility and even dyeing the yarns again. but it allows us also to remove some contaminants that will inhibit the further processes of recycling. For instance, metals that are present and also some finishing agents. So this first pretreatment has that advantage, and also to control the degree of polymerization and the intrinsic viscosity of the cellulose fraction. That, as you can see there on the middle, the dissolution, we can use several solvents, of course, the lyocell process and NMU, but also ionic liquids or dipothetic solvents. We are exploring a lot of alternative and sustainable approaches to do the dissolution of the cellulose. And when we have the cellulose dissolved, we can, in our dope, we can move forward for wet spinning to spin man-made cellulosic fibers. And in particular, I'm showing in the lower circles one approach where we are using not only 100% cotton or lyocell fabrics or cellulosic fabrics, but mixed, and it can be mixed, for instance, with elastane. And there, in that example, in our process, we can recover the elastane, in this particular case as a mesh, that we use as a support for the nonwoven application that we are exploring further. As for the biotechnological processes, it's quite similar. The main difference is that we are replacing the solvents by enzymatic hydrolysis for the dissolution of the cellulosic fraction. And this dissolution with enzymes, we can control the degree of hydrolysis depending on what is the application. Of course, we can dissolve and produce a dope for wet spinning application, or we can just leave it in a raw material state as a pulp that can be then delivered to a pulp mill for producing paper, or finally also for wet spinning applications. But we can go further into hydrolysis of the cellulose, into the reduced in sugars, for instance. And I hope you can see, but we are exploring one way of coating the yarns to decrease the peeling that I was also mentioning the previous application, which is one problem also for quality of the yarns. And you can have an innovative approach to increase the quality of the yarns and also the release of fibers with this solution. But also we are also exploring these reducing sugars as a carbon source for fermentation processes that we can produce raw materials for the textile industry as well. And finally, the net as a support, as I showed before, for these other materials that are present in the cellulosic fractions of waste. So briefly, and I hope I kept my time, this was my presentation, and I'm glad to answer your questions that you might have. Thank you. I don't know if you are hearing.
Thank you so much, Carla.
Oh.
It was really interesting, and don't worry for the timing. We are managing pretty well right now, so we are happy for that. And now officially, we would like to open the space for questions and answers. Also, if the participants online have questions, they can first write in the section questions and answers dedicated for this, and then we can allow them the microphone and camera so they can do also directly the question by themselves. So let's start for the people participating here at Torbali at Sun Textile. Questions you may have, some hand raises now. Nothing. Please, Ariana.
Can ask now because
Remember to say who are you. I know that the PLASTICE members knows you, but others not. So please.
Hello, I'm from Rina and Ariana, and I'm working in a workshop with Rocio. I wanted to ask now because the presentation of Carla just finished. I wanted to ask. You mentioned different ways of recycling. You mentioned different ways of recycling, and I was curious about how energy intensive each of these processes were, and if there's, I don't know, one of them that's less impactful on the energy, because of my background, I'm more interested in this. And yeah, if you could clarify this, maybe it would be also interesting for everyone else.
I'm sorry because
I don't
yeah,
know if you.
it was not clear. Sorry, I couldn't listen properly. Could you please repeat, Lucia?
Okay. Can you hear me well from here?
Yes, yes.
Can you hear me well from here?
Yeah, now it's okay. Yeah.
Okay. Okay, my question was about energy. Okay, it was about energy consumption. In your different recycling processes that you just mentioned in your presentation, I wanted to know if there is one of these processes that are less energy intensive, and if you have any information about that, even maybe something about if you use renewables, anything regarding that. I think it would be an interesting insight.
Okay. Okay, thank you. Now it's clear. Probably you know, but Portugal and we have a strong share of renewable energies in Spain, Portugal. So it's more than 60% of our energy. But in particular, the recycling processes for natural fibers, they are not energy intensive. And that's mean that, of course, when we have the dissolution of cellulose, we need to use some pressure. Depending on the solvent system, we need to use some temperature and pressure for the chemical recycling, but they are not energy intensive as a way. And of course, if you replace these solvents with enzymatic hydrolysis, as you know, they work in a mild temperatures, maximum 40 degrees and no pressure. So they are not energy intensive. As for the mechanical, it's low energy. Of course, you have a shredding of the fibers, but none of these processes are energy intensive as per se. If we are discussing synthetic fibers, that's a different approach and perspective. And of course, for polyester or other synthetics, we need to have the thermomechanical recycling, which we need to use high energy for melting the polymers. But for the natural fibers and cellulosic fibers, this is not the case. And the chemical approach that we are using with ionic liquids and diprothetic solvents, the energy demanding are very low. I hope I was clear. I cannot stop my sharing presentation. I know if you still see it because
If you like, yes, you can do it. It's not a problem. Thank you, Carla. Also,
but
thank you for
I
your
cannot
answer
do
to
it.
the
That's
first
why.
question. Don't worry, I do it.
Okay, thank you.
If I can. No, sorry.
Maybe let me see if I can stop. But
This is not this. No.
No.
Okay, we can force it like that.
Yeah.
I need more time to learn Turkish. One thing is understand how to say teşekkür ederim, but another thing is understand how to say stop sharing the screen. So it's different. Okay, thank you. So, let's see if there is other question here. I see some faces a little bit tired. It could be Eros. Very good. Yes, come here. We know all you, but if you want to
present. Thank you for your presentation. My name is Eros Farag. I've been working for SSN. I have one question about the waste that you produce with this process of recycling and treatment, and also the byproduct.
maybe also, yes, Carla.
Yeah, if I can add, so we, in particular in Text Matter project, we are using post-consumer textile waste. So we launched a campaign also to promote this awareness of the consumer. And we are collecting most home textile waste, so bed linen towels. And that is a wonderful waste fraction because typically it's white or with light colors. So it's a nice fraction, no accessories, no hard parts. But we are using all the waste that is composed of cellulosic materials. And for that, we need to remove the hard parts by one side, but also to remove the contaminants that would block the chemical recycling or the enzymatic recycling. I don't know if I was clear.
Okay. I don't know if thank you, Carla, a lot. I think it was clear. We have also a little problem of communication, but I think it was clear for everyone here. I don't know if the other speakers, maybe Tila or Tanya, have something to add to this question. Okay, it seems not. Any other question?
The only
Okay,
thing that
I will use the, okay, perfect. Clara,
the only thing I can say is,
here you are.
sorry, the only thing that I can say is Clara and some other people whom we have got today are open for collaboration. So let's utilize this platform as a starting point, the beginning for our future collaboration. Let's do that.
Okay, I understood. Like we translate for the people that didn't understood, maybe for the ambience noise on the microphone that you had, Tanya. We agree. Thank you also for participating and also for the three speakers and all the speakers that have been today. And yes, this is our first step for other workshops as we mentioned today. And the idea also we will have the demo sites open in days. So we will also give information to you all to participate. And if you are interested in one specific technology, this is your chance to catch up and to get in deeper in between each technology. But thank you, Tanya, again. And there was one question here from our dears.
Yes, this is also a question to Carla. Thank you for your presentation. I think it was a really interesting project. My question is related to how can easily be reused or recycled the solvents you are using to all your processes, and also if there is of interest the extraction of those additives or contaminants that you are extracting in the solvents. What is the potential of that? It's a little bit in line with what Eros was questioning before, but if you could elaborate a little bit more about it, I would be happy. Thanks.
Okay, yeah. So the contaminants that we are retrieving and extracting on the chemical or first on the color removal approach, we could concentrate them and use the dyes. There are commercially available some approaches that they already use dyes that are retrieved from wastes. So this is one approach, and it's not complex. It's just a matter of purification, solvent evaporation. So it's time consuming. We are not exploring that in particular because the amount is very low. And we are mostly focusing on creating sustainable and cost-effective approach for the recycling of the textile fraction. But of course, and in some cases, we are using this, particularly when we have dyes and strong dyes, because we can use them to re-dye other fabrics, and we can use this waste fraction. Depending on the finishing, for instance, if we have fluorine chemistry that we are removing as well, this is more complex to get a pure fraction of these materials, and it's more cost effective. So it's not cost effective. So it's an approach. You could do it for academic purposes, but to industrially implement it as a viable, cost effective solution, it will not be the case. So we are not fostering that process. Okay.
Is water consumption an issue? Is that adding up to the cost? Water consumption? Water consumption. Is that adding up to the cost?
Water?
Water consumption. The amount of water that is needed for recycling, that is adding up to the cost. That's also an issue. Do you think so?
Yeah, our processes are water-based, all of them, but we are using this, for instance, for the hypothetic solvents approach that we are doing research and we are employing. We are using natural-based materials as well that are not environmentally harmful, so they are not producing critical wastewater. So of course, we are using water-based solvents, but with low contamination that we can easily in conventional. So our process is less pollutant than a conventional dyeing and finishing that you do on the textile industry. Okay.
Great. Interesting. Also, this crossing between questions between speakers, I think is really interesting. I would switch one question to Tila that didn't have the chance yet to get a question from the audience. And in particular, okay, you mentioned that Eco6X has 3 years already been a platform for this kind of projects and allowing different stakeholders to share their solutions. So this workshop, as you know, and we discussed in the past together, has the meaning and the objective of highlight common barriers, but also try to see how these barriers can become into opportunities if we collaborate together. So in these 3 years of experience, have you in mind just a kind of reflection or maybe analysis that you can do in terms of, okay, in general, the main aspects we have been seeing crossing every project, independently the specific method for recycling textiles employ, or independently of the size of the time of execution of the project, which are the main barriers that maybe you saw that after some time became into opportunities, if you have something in mind?
Thanks for your question. It's quite a difficult one because there are so many different projects working on recycling, and I'm not working on them, so of course it's always a bit difficult if you have sort of this oversight function to then also give really detailed answers, and especially your question asking about from challenges that then came opportunities. It's also tricky. But I think what I can say is that well, there are all these different projects that address all these different aspects of textile recycling, which is also something that obviously through the calls right from the European Union was supported and will also continue to be supported in the next years. I think a challenge that always came up again and again is, well, the question of financing this and like the economic viability, as I'm sure you all know. And I think I'm not sure if that can turn into an opportunity somehow. I think the person that finds out how to do that is doing then a great job. But I think it's possible, and I think it's really something where you see these public-private partnerships coming together and are really needed. So something that is also happening, with this Textiles of the Future public-private partnership is something that is really important, because in the end we also hear a lot of talk about upscaling the solutions, because many solutions exist already, but they now need the financing to then scale up and then also become economically viable. And that's something that can probably only be achieved if you put together the money from the private, but also from the public side, so from European level or national governments.
Thank you so much, Tia. I think that you touch also an important point that we will try to connect, and we will try to answer to the questions I made to you also in the next session. So let's try to see how we can at least identify and then try to see how together we can find matching or melting points if we go more technical, to transform some of these common challenges that we have been listening to today into potential opportunities, even when the competitivity among financing is there present in the background. So how we can prioritize and also be strategic. So thank you very much. I think that there is no other question. I'm just trying to see also if virtually there is some people reacting. No, it seems not. However, we still being 33 people from this morning. We were a little bit more, so it's a good number. Thank you all for being here participating. And now we go to the coffee break. But before that, I will ask you to all the audience to congratulate with a big applause to all the speakers of this slot. Thank you so much.
Thank you.
Thank you so much.
So we are coming back in a few moments. Just remember that we have the enabling session at 3:30. Sorry, yes, we will start in 10 minutes. So you can stand up, chill a little bit, recharge with a little bit of caffeine, and then we came back. Thank you so much.
Thank you. Bye.
Bye. Thank you.
Thank you. Okay. So also, literally, are you still there? Are you listening to us properly? So now we will start in what I like to call enabling session. So the idea is all the things we have been listening to the different experiences, platforms, projects. We have a project today, but also companies. So all the different perspectives we get from insight from today should be came out here, and we should try to. I will help you. This is the role of facilitator. So I will not be here then and just looking at you to see, okay, speaking the 2 hours. Please don't be afraid. I will not speak 2 hours. The idea is to make you speak, reflect, share, introduce yourself, and make this a space for you. It's for that it's called enabling session. So as we said today, one of the key things is try to see, okay, this is the challenges. I think it was pretty clear how are the challenges interconnected and how different they are. But also we should try to see how we can link these challenges between opportunities and which role each of us, different organizations, could take place and how. So so just a bit remember for the people online as well as people present here. When you talk, I will ask you to speak louder. If you take your air from here, it's easier to speak louder. I do 3 years of theater, but I will not make any improvisation of theater here, I promise. So introduce yourself, your name, in which company or organization are you working on, in which field, and then your first comment. So I have been taking notes because I have been paying attention to every speech, word, and even question you made today. So I would like to start with 3 keywords, and they maybe invite some of you to tell me what you think about these words, or maybe how you can connect these 3 words. So first we talk about traceability. Then also we talk about value chain that are really interconnected. But also one of the last things that Tina, for example, mentioned to us, it was the funding opportunities. So, for example, from a perspective of our research project with the European Union, we have a limited budget, specific methodology to follow up for developed technology until a certain level of readiness. And the thing we need to understand, okay, the value added is the project itself, But the real conversion that we can have and the real challenge is replicability, how we can scale up, how we can translate this into a real solution, a real technology to be included in industrial processes, to be included inside the processes that different size of companies have to take on to accelerate recycling, sustainability, circular economy, call it as we want. So, for example, for this side, that this side it was really nice because also we have Clara, but from this side we get today 3 questions, and they are winning. I mean, they are the winning side. So guys, I know we have more Turkish people here, and I would like to hear more Turkish. As you know, I'm really putting the best of myself. I already learned 4 words in Turkish today. And this is a lot for me. And I think that's a really nice language and it is really curious also. So from this side, who will be the first brave person to say something about these 3 words? Do you remember the 3 words? We're paying attention, feasibility, value change, understanding. Well, funding. Oh, but you are afraid of me. I don't bite. I promise, I don't bite. Opportunities. Yes, exactly. Okay, you start to practice. So from this side, maybe who wants to take the first brave word? Something. Don't make me start to look at the intensively to someone in particular because it's a little bit awkward. But if you want to force me to do that, maybe I will do it. I don't know. From here, and you are escaping. Hey, it's okay, don't worry. So, from the business side, for example, from the private sector, the funding opportunities are linked to what? You need to be some. Well, you basically, they are winning, guys. It's not fair. Okay, for no, it shouldn't. It's a thing of competitivity. Yes, Eros.
I have a comment for start.
Perfect.
I think that the starting point should be, because it's not the size, not my sector. But the question is, what is the ability of the textile industry at the moment?
I like that.
For example, are the cost is too high, environmental impact is still a problem, or CO2 emission, I don't know, or other pollutant. There is too much waste or dangerous waste. There is no byproduct symbiosis with other, or necessity to find the symbiosis with other industry sectors. For example, byproduct for one textile industry can use it in another sector.
Mm-hmm.
So this is be the driving force we have to evaluate it with the need of the industry, the private industry, of course.
I like this. I like the first question, and I think it's really interesting. I don't know if someone else has something to add. We are just taking one perspective, the need of the industry. So today, for example, we have Carla that she said, we are market oriented. So it's other way to translate your question initially. Okay, how we can develop our technologies, prototypes into market oriented technologies. So we need to understand what they need. But the thing is, we should, in that case, specialize, as you say, which industry, and then you tackle directly to the textile industry. So I think it's a really good starting point. Thank you, guys. Anything in mind? For example, in the side industry, we have different companies, different size, different approaches, different industrial processes, and maybe they are having problems in different parts of the value chain. No? Any idea? I mean, we work all days, we have problems all days, Sometimes there are colleagues the problems, I know, but sometimes the problems are also related to these kind of things. So I think that you have in mind something. Are you able finally to share?
The Turkish textile production nowadays the price is very critical for us. So the salaries are getting increased, but also the materials also increased, but or we are importers. We work with Zara and the price are the same, but we sell to them. That's the critical point for Turkish production factories. I think is the main problem. But we are a Turkish company, but we import our products to European Union, and that's why we obey the sustainability and eco-design rules and other policies for European. That's the tricky point is for us. Also, textile industry has different branches in it. We are a garment producer, but there is a technical textile part that can be automotive textiles, can be medical textiles. Every textile part has different needs, different technical specs they have, and also the customer needs are the critical point.
Yes, I know. You know,
Another point.
you just
The last one, then
you just talk. No, raise your hand.
I make an example for the cosa industry, maybe it's the PLASTICE industry, textile industry. In this industry, there is at the moment the green steel, someone called green steel, and I try to explain. So the final customer sometimes requires the buy money with some environmental less impact environmental products. For example, they want to produce steel not with carbon, but with other material that is not so dangerous for the environment. I don't know if it is possible. Maybe yes, because for the textile industry in terms not for environmental impact, but the use of some kind of certification that show you that these clothes, these jackets are produced in without use, for example, work of children or the people that work in this industry are well paid and so on. So some kind of certification that the products are sustainable and they use the workers are in good environmental, good paid, no children and so on. This is the other point.
I think this is interesting, and we are linking different challenges. As you mentioned, Eros, just to connect the first comment that you made, the need of a particular industry that also should be also classified by the type of technical process that you have for the end client and the end product. But also, we are talking about, okay, we need to be competitive first here, and also in the market we want to go. And the thing is, it's a thing of time, but it's a thing also of asymmetries. And I think in this part is when we have to try to include which kind of actors. We are talking about the perspective of being market-oriented of industries. Also, we are trying to include small and medium enterprises, as today Mr. Beben mentioned. So, in this part, I think that we already are detecting the role of who, for example, who can help us, for example, if we don't have compliance, we don't have certifications. When we try to sell to the European Union, we have to pay more. We will lose. As today Humberto Lopez from World said, if you want to have the compliance, if you do regulation, you can post it's a cost of opportunity because you do now or you do after. But the thing is, how I arrive to fulfill this gap.
I see that there are a lot of people in Europe that can pay something more, but to be sure that this jacket or these clothes are produced in a green way, without exploit children or.
I like this. There is also one point that is we are thinking about what we can offer, our traditional products, our processes, our current moment of how we have the fabric, how many machinery we have, etc. The technology is available at this moment, and also in that side enters this research project with new pilot technologies with potential to be introduced into and maybe enable and facilitate this gap fulfillment. But also in this, you talk something that we can relate with other of the comments and questions we have today. It's raising also in the side of the demand a type of product that should be sustainable, that should be traceable, that we hope should have available the data about from where it comes. It comes from a cleaning, let's say, no forced labor pathway or not. So there we are slowly being able to connect all the things we're talking today. Yeah, please.
The consumer wants to buy more sustainable clothing, but they don't want to pay more. So the consequences of just studies, the prices drop, and the Turkish producers are known for bad quality other producers. So we're overwhelmed with quality clothes in Europe, and at the end of the value chain, we are overwhelmed with all the textile industry. So it's not needs of the textile industry. I think textile industry is like how to say it, really upside down today. With less quality clothes, and that want to do well cannot afford it anymore. I think that's the problem today and challenge today, and that project like PLASTICE and other ones we start today are trying to find a solution.
Thank you. I think this is really interesting because I remember when we have also years ago, without talking about specific presidents in other continents, but you would understand of who I'm talking of. But before it was no, renewable energies are not cost efficient. They cannot compete with traditional ways of energy. And now, the last few years, we have seen that the renewable energies show that they can be competitive in terms of energy performance, but also in terms of cost efficiency. I think that we are in the way to arrive for the same for the fashion, but the problem of the fashion industry is that it's based on trends. And why the trends are based in a circular value chain, this is difficult. So also your point is also connected with this. So you said, okay, they are not able to pay more for something that's good quality that we go from a real circular economy first. It's true. But what we can do in the meanwhile, because we are looking for current moment, the present, we are taking a picture of today. We know how well have been in the past. How do we know what should be the ideal scenario? Perfect. There is something that governments can do, that World Bank and the European Commission, in addition to what they are starting doing, we can do. We can think that maybe, okay, we are thinking this as we always make sales and we always sell to Europe. There is something I can change in my way to sell to Europe to maybe combine and change a competitor, maybe, I don't know, and became a competitor, maybe an ally, just to try to reduce a little bit the gap, the symmetry, and then be able to be more competitive. That is something that I shouldn't do alone as a company in Turkey. I should do together with some other companies. Or maybe I can be stronger reducing the gap if I am together with other two companies. I should start with only one end product or focusing on only one client. These are nice questions and difficult to answer now, I know. But maybe you have also other questions to add. The good thing is we start to think about this. What we can do. What could be, sorry. It's clear the focus that we have oriented to the market, the private sector. And I think that is also one of the focus that World Bank and also the private arm of the World Bank that is IFC have. Maybe after this workshop we have a specific idea of somehow something more in particular we can discuss, and maybe this can be financed by one of these organizations. Who knows? But we need to try to, yes, understand the link between these, the challenges, and see if there is maybe some kind of way to arrange something legal in the short term, short, medium, short, I don't like it. But yes, maybe for this time we have some other comments. I had the pleasure to have this beautiful Turkish lady together in the same table today. But unfortunately, I couldn't talk along with them. Maybe they have something to say. No, this is not. I don't remember Jose is smiling in Turkish, but don't worry. It's okay. Today, also we talked about sizes, sizes of companies. We are talking about other kind of stakeholders. And I think that here is also, there is an important point that is, we are also thinking in the macro level, but we are making pilot projects at the local level and small scale. So maybe if we are now doing things at small scale, we can also start to look for allies at small scale. For example, maybe local governments, what they can do. They don't have money as national governments or multilateral institutions, that's true. But they can maybe help us to understand better how we can match this other concept that emerged today that was public-private partnerships. This is other key work, I think.
It is quite related to this one, maybe what we were mentioning before. From my perspective, especially compared to, let's say, the plastic value chain, in which apparently the circular value chain is much more promoted. We are now developing projects very focused on improving the sorting. Each country or even each region has its own strategy to do the separation of different fractions and improve this recycling rates and so on. I think in textile we are still in a very early stage. I mean, the initiatives that, I mean, just not only thinking about chemical recycling, we can do a lot of things before that. That must be done indeed, because many of the clothes can still be useful to other people, and maybe you just promoting second-hand markets could be a strategy that is can be quite easily be promoted by the public and also the private sector. And I think it is something that it's not really, it is maybe cultural. This culture of consumism is quite dangerous in that sense. I think new generation, as Umberto, yes, was saying this morning, I think they might be a little bit more conscious about that, but previous one might not be that case. So I think it's a question also of changing the mindset, but it is not like, yeah, let's be super eco-friendly, everyone, and let's go to second-hand markets. Well, that can happen, but it is something that the public and the private sectors must invest in. So I don't know exactly the formula how to do this, but sometimes I think we are putting too much pressure on developing technologies recover fibers from textile that can be easily reused for other purposes. So I think that first stages of reuse the material are not fully developed, and maybe you can provide more inputs about that. I think what I see in Spain is sometimes I hear about projects and I have no idea that was being developed because no one makes equal of that. So I think we have, as society, we have to work more in that part. And let's go for other technologies to recycle that are really applicable to those wastes that cannot be used for anything else. And but maybe just recovering fibers or reusing as feedstock for other processes, whatever. But from my perspective, it's just also a societal issue. We are not paying attention to that. We go to the easiest way, the cheapest way, more and more and more. It's like, oh, we don't have even an implemented system to recover or to recycle or collect the waste, the textile waste. It's like, I don't want to use this t-shirt anymore. What can I do with this? At least in Spain, it's like, yeah, you have some containers, you can put the clothes there, but many people don't know that. So it's just also a question of information, and that's what we can do as individuals. But obviously, we need support from institutions and also the clothing industry. I mean, making like second-handed websites for market or whatever, but it is something that should be promoted. Or otherwise, it's going to be really difficult. Because the value chain is not well established, let's say. It's not circular. We can do a lot of really nice projects, but if the value chain is not well defined.
I mean, it's even difficult to make a circle with people. I mean, because not everyone has the same perspective of a circle. Imagine to try to force a circle just from one movement. It's not easy from one moment to the other. And that is a good thing. Okay, we have the value chain, we have the fragmentation, the own way to be. Let's try to slowly try to give a way of circle. There was a question there.
Yeah.
Thank you, Clara.
Clara. The simplification side, because I really agree with it. This was exactly what I was thinking about while we were listening on the research and you guys. And I saw that some of these associations are working with university and but I was missing just a bit of viewpoint from the lower education side and even full sector. I think point of younger generations have become decide that this is an important issue and that the sector will be able to address this issue. Then the consensus of the social side starting from the young generation. Those are the ones that have the subject memories and the abstraction. I am in that sector already, but older people, my parents as well, they don't really think about the question. They're not used to abstraction, but we are. And I know that my younger generation, they sometimes lack education. And but we just have initiative and go into schools and the change and be an easier way, what's an easy way, what's a way, what we found that yeah, that's what I was saying. And maybe there's some sites from the speakers from earlier, I don't like this. But yeah, I would missing this side of the presentation.
I don't know if online there is someone active actually. I mean, I understand in any days. But I think this is really interesting because we are linking everything we talked today, and this part of the education, I think, is interesting because we are also finding not only the links between products, the interdependency between them, but also, okay, which role should play everyone in which things. And also one thing, the existence itself of the technology didn't mean that this technology will be effectively implemented, even if it has the potential. So we are also from PLASTICE trying to set the connection between industry and our technology to ensure replicability and to ensure that the real effect and the real potential that we are developing inside can be a positive impact and help to accelerate and reduce, not solve one from one day to the other, but reduce the gap, the asymmetry. One thing I think that maybe for next workshop we should implement, because I know people and I have the products, we can include also UNESCO people. And they have, I mean, probably you all know this, but there are two types of communication, formal, three types, but you have the formal, to make mention to the ones that Ariana mentioned, the formal and informal. The formal is the university and this academic level to talk about difficult things as we do today, that maybe are obviously necessary, but it's difficult to say in a simpler way. So someone that maybe doesn't have the expertise can understand. So also I think that one of the barriers we have in terms of awareness is to make it understand. How would they simpler this? This is also a challenge we have, and we do a lot of exercise inside the communication plan that we have inside our project. And I think it would be okay to mention this because probably it's something that in a different way, but having the same tone of color, we're talking about textiles. Also, companies that produce textiles, for example, I want to do a product that is more socially responsible and environmentally responsible. Yes, but how I explain to the consumer or to my client the benefits of this? How I explain also the difficulties to arrive with this. And then we have also informal education that I think has this way, because informal education is the one we get, for example, from social media. It's information that provides not for formal channels. It's not a certification that I finish a master's degree, but it's different, it's bigger, and it has other way to react. So I think this is what really interesting. I don't know if there is other comment or maybe other link you want to add into this conversation, but the idea was to have this kind of reflection, to have this opportunity to link things. Obviously, we will not resolve this problem today, but maybe someday tomorrow, and maybe this conversation can help to understand the next steps, to understand the next specific discussion we need to have. And with this, I will read the memorandum of understanding that I already mentioned this morning. The idea is the organization that wants to sign this is not, let's say, binding in any legal way. It's just expression of the interest and manifest the real spirit of today, of the people that have been today participating, and of all the challenges and opportunities. And I think that it's a good resume, some way of what we said, of what your voices stated today. So first of all, I will ask you a really good and nice and happy applause. And before going to the final words that will be stated by our dear project coordinator, Emiliano Mesarenas, I will read the memorandum of understanding, and this will be sent to the people that requested. If you don't do it at the registration moment, you can still manifest this to any of the PLASTICE members. And we will send this to you. And obviously, what we want to do is add this into the social media of PLASTICE, because it's a willingness, but it's also the first draft of the roadmaps we have to develop together with companies as part of the project results. So, okay, let's hear a little bit. This memorandum of understanding is that is established aim on the organization participating in the PLASTICE in Action workshop held at San Textile on 14 November 2025. The signatories expressed their shared intention to collaborate towards strengthening circularity and advancing sustainable textile and plastic recycling systems across Europe and associated regions. We collectively recognize the urgent need to accelerate the transition toward circular textile and plastics value chain. These transitions require strengthening recycling technologies, enabling markets for secondary raw materials, improving regulatory coherence, and fostering multi-stakeholder collaboration. The signatory organizations affirm that no single actor can overcome these challenges alone. Instead, meaningful progress requires joint action across industry, research, policymakers, and civil society. Throughout the workshop, participants identified several cross-cutting barriers that hinder the scale-up of circular solutions. These were categorized during the enabling session into three main areas: technological barriers, limited fiber identification and sorting capabilities, complexity of multi-materials, textiles, and contaminated feedstock, early stage scalability of enzymatic, thermal, and chemical recycling pathways, quality variability in recycling outputs, economic and market barriers, high operational cost compared to virgin materials, uncertain long-term market demand for recycled feedstock, difficulties for SMEs to access investment and pilot infrastructures, lack of consistent secondary raw material streams, regulatory and systemic barriers include fragmented implementation of extended producer responsibility, lack of harmonized traceability and data standards, insufficient alignment between textile and plastic regulations, limited cross-sector coordination between industry, research, and public institutions. Participants identify several solutions and collaborative actions that can be advanced collectively. A. Knowledge exchange and capacity building. For example, joint training modules on recycling technologies, after the one we mentioned today, with SMEs and European platforms. Replication workshops based on demo-side outcomes. The next two workshops, for example, on the organized arena in PLASTICE projects, will be part of this, and also we will be inviting you to the demo site open day, as I already mentioned, as well as cross-sector dialogues, bringing together industry, researchers, and civil society. I think that we should add some stakeholders more there to that line. This is a draft. We can also add some things if you have some thoughts additional to this draft. Then we have the shared testing of sorting and fabric identification technologies, harmonizing quality criteria, and collaborative assessment of circular materials performance. In the policy coordination and system-level actions, we have some points like alignment between European API requirements and traceability frameworks. Also, I think that the European projects, they all develop a part of regulatory compliance, and they can support SMEs and industries in how they can reach. They can be a reach of information to arrive to this compliance. Exploring joint funded opportunities for scaling circular processes. And then we have the voluntary commitment of the signatories that are 6 points, basically to continue the collaboration, share knowledge, technical insights and best practices, explore concrete joint activities, promote aligned communication and circularity and sustainable recycling. So this is part of awareness, for example. Seek opportunities to replicate and upscale demo-side learnings, and last but not least, contribute to policy dialogue. So, as I said before, it's non-binding, but it reflects a jointly declared commitment that we want to, in some way, to be the written, let's say, outcome of this workshop. So, thank you all for this. Thank you all for also giving this contribute today and these really valuable insights and perspectives and experiences you shared. Your time is really valuable for us, and we are really thank all of you in person, virtually, to be part of this workshop. We invite you to be part of the next ones. And we hope to keep in touch. And thank you very, very much in representing all the Textile Consortium for this. And I don't want to give the word to Emiliano before saying that I have to thank from one hand in my heart to the Sans team, to the Time Textile team that has been really amazing during these days. Not only we have the GA, the General Assembly, the 2 days before, so they have been already working a lot and they put also its hope on this. This event will not be possible without their support. So thank you so much, and I ask you a bigger applause for them. But it's not all. I have more things to say also to the people that is connected online, to my colleagues from Riga side, but also from ITIL side, and to Silvia and Diana that have been there also supporting me in everything at any moment. And it's difficult to do that, I know. But also to Emiliano that has been also guiding us and facilitating all the organization behind this, as well as all the speakers we have today that were really interesting, well seen, really qualified. And it was amazing to have this opportunity to hold this workshop with you all. To Clara also for the opening words, because you have a really excellent participation. And I think that if you have not been the chance to be here in person, it will be totally different. You made the most questions of today. You are the winning person of the questions. So those, you know, if it's a class. Okay, and this is everything from my side. So now you will not hear me talking anymore. You should be happy. But after the final words of Emiliano, we'll ask you a quick photo just to have the evidence that this moment existed, because we are in this modern world and we need photos to show that we have this workshop. And this is everything. Thank you. And a big thank you for
Hello everyone. I'm Emiliano Mesa, and together with my colleague Clara, we are the project coordinators of PLASTICE. Well, I joined Rocío's. I think she did a great job thanking everyone for being here, not only in person, but also our colleagues there online. And also thank you very much for this. We know this has been a great effort from your side, joining everyone, many hours behind, talking to each other and trying to do the best to build up finally this great result. I think many new opportunities will rise from this conversation in this workshop. This is the first one of the other two that are upcoming. And a part of this result that we can get in this workshop, as you can see, we still have 2 months to finish the project, where the rest of the pilots will be as well up and running. And this will be as well a way to showcase how the consortium is really robust and really confident about the technology that we are developing. In fact, the results that we are gathering here, I think that would be deserving to be noted as well in terms of the opportunities and the chance that as we were mentioning as well, we can build up with different SMIs in the European context. So these kind of actions, they are very valuable for the European Commission and also I think for us as well. Well, finally, a big thanks for the consortium. As you can see, not only working with Clara, which is the winner for this prize that we've been making it amazing, but the rest of the consortium as well has been getting supportive for the day-to-day work, and I think future projects can raise up together to continue with this great opportunity. So thanks a lot for this participation, and well, I hope we can cross our paths in the near future.